workshops except for the install class. The only time that we may have recording is we have that hasn't happened yet. And so to find the recording afterwards, we do link it on our website along with the materials. But if you want to see it first, we do have a YouTube channel. You create it to data side, and I put it up there, and then the link goes to our website. And this week, oh my gosh, I need to know that one thing. Just pop on to YouTube, and you'll be able to watch the video there. And you, oh, that's great point too. If you want to learn more, so we have some other series that we've recorded from recently. One is Beyond Basics and Art. Another one is Our Fundamentals. And I recommend Our Fundamentals as a 4-part one. That you watch that one next. That's a good continuation. By fundamentals, it's not elementary, it's not introductory, it's actually fundamentally how does R work. And Duncan thinking that one knows more than anyone else about how it works in that way. So, can you check that out? Okay, that's my skill for this morning. There is a sign-in sheet that please just make a right next to your name so that you know that you came back. This is really important information for us to know to be able to assess our program and ensure that we're reaching all of our target audiences. So without that, thanks for your patience this morning.
Okay, thanks, Pamela. So a big part of this, as somebody else was saying yesterday, a big part of this is you've got to actually practice this every day. It's just like any other language. If you're not using it frequently, it goes away. You learn, and you also learn a bunch of stuff by actually hanging out with people. This is one of the purposes of the data science initiative, is that there's a whole lot of people from different disciplines, each of which there's 1 or 2 of you in your programs that are doing slightly different stuff than your program was originally designed to do, and you're all by yourselves, whereas you're actually collectively all together if you could just meet each other. That's where the Davis R users group is helpful, or just this space here and just actually hanging out, creating your own little working group. So yesterday I couldn't take the train, so I didn't get a chance to actually put together some stuff that I wanted to put together. So I got a little bit of a chance, a tiny bit of a chance. I suggest that we just spend about 15 minutes total. Here's some questions, okay? Very simple questions, progressively not so simple, okay? Just take 15 minutes to actually work together with somebody beside you or by yourself, or just ask questions, okay? Maybe 10 minutes, just to actually just go ahead and practice what we were doing yesterday and see if you remember any of it. And if not, yell, okay? Go, I'm stuck, I don't know. I'd like to do a lot more practice with this stuff, so let's just do a little bit of it now, but not too much. So 10 or 12 minutes. Just try to go through, read these quickly, answer your own question if you want. And if you want any reminders of things that we talked about, what you'll see in these is it's a whole lot of subsetting, because that's what we spend all our time doing. And yell if you have any questions. Jane will answer. There's a seat there if you want, or there's other seats. Wherever you want.
I was messing around.
It's not a morning quiz. It's not a quiz. It's just, I can keep talking. I really can keep talking. I just think it's more fun for you guys to actually do something. But if not, I'm happy to keep talking.
Oh my gosh. Reasoning through why you convert your decision. Oh, that price.
That's the
15.
Yeah. It's which?
The minimum price.
Yeah.
It's the average. I got a 15 back.
Yep.
Not legit.
I don't know. Now what you want to do is go take a look at the whole entry to see, is it really legitimate or what is it? Okay, because this is what we do. We look in weird things. We gradually clean the data.
Yeah, I remember when I see the list there.
That doesn't seem legit.
You gotta look. Yeah, people throw stuff out. It might be per day. Who knows? Even that. Per minute.
Fire thing.
For STR,
Four.
Nope, not it.
What's a mess?
Oh, if you choose STR.
Oh, STR.
To remove the a piece of data from the data frame. How do you do that again?
I told you yesterday. That's okay. Just think about what we talked about yesterday. How do you actually, so you can, subsetting is a huge part of it. So you can pull out all the ones you want to keep, or you can drop the ones you don't want. How do you drop the ones you don't want?
Something more than calculating.
Not necessarily. Not necessarily. Remember, if you knew the observation number, that's one way of doing it. Yeah. And then if you knew that, then you could put a minus in front of it because that's how you drop. I know. Thank you. I like that. That's right. That's right.
My notes are almost unreadable. So I'm like scratching at the same time.
Oh, that's not good. Then this hasn't been helpful. So
No, it has.
So-
I saved
So
everything.
so today is the day that we make it. We try to make sense of the notes, kind of. So
Should I come with more confidence today?
no. You just come with questions and come with like, okay, fine. We covered a lot of stuff. Now we got to pull it all together. And with yeah.
We learn. Yeah, view and then Davis.
There's no learning around here. Ooh, good.
Yeah.
It doesn't like capitals when you don't when. Whose cap is this? Whose cap? I thought it might be yours. And anyone recognize this? Anyone know who? Oh, excellent, good. And that one's gone. That one's been there for 6 months. Unless somebody wants it.
I wanted that.
Oh, I'm sorry. You got to move fast. It's just minding it permanently.
John's always like funny and they put it on people's lawns. It's like, oh, is that free? Or they give it that away? Or, no. It's just what? Oh, gosh. And then how do you do that?
So you want to delete that line and get it out of your data set. Is that possible at this point? Or you just keep it on?
No. You want to get rid of it because it's going to show up in plots. It's going to show up in all these computations. So if you want to get rid of something, you got to.
I can delete
No.
line number
No.
1.
No. So we got all these things that we've learned, and today we'll try to assemble them. But remember, if you got a data frame D, if you knew the row number, you could say minus 10. No, that will give you back a new object, which is a copy of D, but with that row gone. And you could then say D2 equals this thing. Okay, but but now you have to find out which row it is, or you, okay. So, but you may not want to remove it from the original data set, but you may want to create a new data set that actually has. They're just creating copies or new variables. That's a way.
Alright, I'm thoroughly lost.
Oh no!
Or not thoroughly lost.
Okay. Oh yeah.
Thoroughly lost in my own, but it's all relative. So how do you identify, so once you've identified the minimum price, how do you pull out that set of data, that line of data from the data frame?
Remember what we were doing? So one way, but what we were doing was we were basically saying, okay, let's compute the minimum of, I'm going to call it D for Davis, D dollar price. So now we've actually got that minimum value. Now we need to go find out which rows are equal to that, or which rows have a value of price. So we now say D dollar price equals, and that I'm going to call this W for kind of which or what, or, okay. And this is now a logical vector that is trues and falses. Okay, and again, I test everything afterwards. Table of W, that'll tell me how many trues and how many falses there are. I should check the class of this too, but if I'll just do it here, and hopefully I'll just see the trues and falses. So now that's giving me a logical vector. And then if I do something like this, this will identify, this will pull out the rows, it'll pull out all of the columns for just these rows which are true, remember? So we can subset by a logical vector, which is the same thing as, if we put in which W here, we just don't have to, and I don't like typing any more than I have to. But that's what we're doing here, which one are we doing here? Find the observation, or maybe multiple ones with the lowest value for price. So here's the lowest value of price. Here's a logical value, a logical vector that says, is this observation, does it have the same value as the minimum price? And now we can go in and pull out that observation. And then we can look at the whole thing, all 19 or 18 variables, and say, does it actually make any sense? Has anyone found it yet? Anyone know why it's only $15? House cleaner in Houston. This has nothing to do with the actual location that we were scraping. It's amazing. I don't know. I have no. Yes.
So that would just remove the one value that's the minimum. Say you had another value that's like 17.
17.
Yeah. And so if you do that, it will only remove the ones that are 15 or equal to 15.
We didn't. Okay. So just to be clear, we haven't removed anything yet. Okay. We just said, tell me the ones which satisfy this criterion. Okay. Then show me all. Then go get the subset of those observations or rows in the data frame and show me all the columns. Okay. You know, I might go and look at I might go in here and type quote body here. I want to look at the body. I'll read the whole posting, and that'll be sufficient to actually say this is nuts. Okay. So this will just show me. Now, if I wanted to get rid of these guys, so there's two things we want to do. Okay. One of them is so I started off with a data frame that looks like this. And then I ended up with a data frame that just looks like this, one row, because I just wanted to see it. Then I make up my mind and say, you know, that one's just garbage. Okay, but I'm a little conservative. Okay, I'm going to say D2 is equal to D not W. Okay, what's this? This is W, which is this. This is trues and falses. True means it is equal to the minimum. So not W, okay, means turn all the trues into falses and all the falses into true, okay? You can write this as W equals false, which is kind of weird. If this is false, if the value in here is false and it's equal to false, then the answer is true. Okay, this is starting to get a little bit weird. Okay, so let's not do that. This is just invert the trues and falses. It's just my way of thinking about that. So now this one will actually say, pull out all of the rows which don't match the minimum, and then assign it to D2. Okay, now we could then go on and try again and repeat the same process. Find the minimum in D2, and then you get 17, let's say, and you go look at that one. Alternatively, you can say, okay, so is that clear? That you could just repeat the process. However, the same logic works, which says, we said, fine, this is the condition I'm looking for. Well, what if we just said something like, you know, I just don't want to see any apartments less than $50 because they're probably not apartments, okay? So we may make that up, or we may look at the values of price and then say, you know, it looks like $200 is the minimum that I care about. So we could change this to be, W equals D dollar price, okay, is less than, let's just say $50. Okay, and now that's going to include multiple observations. Actually, I don't think it will. I think the next minimum is actually real. This is about $600. But this would actually potentially pull in more, and then we just drop all of those guys. Okay? Happy? But again, all it is, and again, there's a principle here, is that this is trues and falses. We can make the trues and falses in using any condition we want. I could say it's the minimum price, or it's less than 50, or I could say, I think I had it here, or we could do something like this, okay? And I'm not saying this is a good idea, but we might be interested in, we could say, hey, go and identify the ones where the number of bedrooms is less than the same number of bathrooms. Okay, and this is going to go element by element. So each observation is going to compare that observation's number of bedrooms to bathrooms and go, hey, this one has more bathrooms than bedrooms. Bit odd. Okay, potentially, maybe not. Now let's go and investigate those. I suspect when you do this, as in that question, you'll find out that I probably got the number of bathrooms wrong. Okay, it's not that it actually has more baths than bedrooms. It may be that the posting was wrong, but it's also more likely that the code I used was wrong because I was taking shortcuts. Okay, but this is just a logical vector, and now that's a different condition, and we can then we can repeat everything here. So drop all of those guys, or just look at those guys. Okay, and that's all we do all the time is start looking at groups. Okay, subsets that we care about based on some condition. Everyone happy? How are you guys doing? Again, the point of this is to try to practice and play. Okay, when we organized this, we said we'd go till 1 o'clock today, and then we'd say, and afterwards I'm around, and we can go beyond 1 o'clock today. We can also just go and do you can sit here and actually practice things and ask questions. So the practicing is absolutely key. As I said, I didn't quite get a chance to do it yesterday, partially because there's too much to cover. But you can play with these. You can come up with your own questions and just play and ask, how do I do this? And hopefully all this stuff will become reasonably clear. Okay? I mean, again, all we're building on is, this is just vectors. We're pulling columns out of a data frame. We're comparing things. We're doing subtraction and addition and so forth. We're then subsetting the rows or the elements of a vector. And this is all there is to it. Okay, we do a huge amount of this sort of thing. Okay, let's just. So let's just do this. I'm gonna type in here rather than in our studio. I'm gonna type over here. Are there any questions about what you did over here? Okay? Does anyone want to talk about any of these things or recap anything yesterday? No? Yes. Yes.
Could you briefly go over the adding column?
I most certainly can. Okay. So let's add a new column to the data frame. Okay. So that's first of all. Okay. I want to measure. For some reason, I may actually want to use this. Okay. We can look at the relationship between price and square foot. We may also find it useful to actually just compute the price divided by square foot and then look for weird things there, or use that in a model. So we want to compute the rent price per square foot. So the way we do that is very simple, okay? So there's two steps. One of them is to compute it, and the other one is to put it back into the data frame. We may not want to put it into the data frame, but I decided we did, okay? So what do? We basically say, what do we actually have here? We have Davis. So let's just, okay, I'm coming back to this after a while. Let's just check. This is what I think it is. Let's go and take a look. Okay, good. It's got 175 observations. This is the one I want. Okay, so now, and we just check. I mean, I do this all the time. As I just remind myself that we really do have what we think we have, as opposed to getting surprised later on. Okay, so what do I want? This is very simple. Davis dollar price divided by Davis dollar square foot. Yes? And there we get all those. Now we get missing values because the price or the square foot might be missing. Okay, we can take a look and see what it is. We can, again, remember, these missing values are important, but we can say Davis dollar price. How many are missing? There's none missing in there, but in the square foot, we do actually have some that are missing. Before we compute this, before we compute price per square foot, we probably want to go and fix the square footage if we can. Okay, we might want to look at the posts and see if we can actually compute the square foot, but that's fine. We can always fix them up later on. Okay, so now what do? We go back over here. So the only thing that, okay, we've computed the price per square foot. Yep. Now all I need to do is put it back into the data frame. Anyone suggest how I do that? I'll give you a hint. It starts with Davis, because that's where we're putting it. And I'll give you another hint. It goes on the right-hand side. Okay, this is the thing we compute. Now I need to put it back in here. So just guess. And I'm going to call it price square foot. I need a new column called price square foot. Okay, I could type price per square foot, but life is short, okay? So I kind of want this. Okay, and now the only thing I need to do, how do I get a column out? The dollar sign. How do I get a column in? The dollar sign. Remember what I said? The subsetting works when you're getting stuff out or when you're putting stuff in. So I will now just create a new variable which contains this value. And as always, I tend to do this first, check to see it makes sense, and then shove it back in later on. But I sort of do the calculations in two steps. There we go. And then what is the class of Davis dollar price square foot? It's numeric. What's the names of Davis? Oh, look, we got the price square foot tagged on to the end. Life is good. So we just shoved it in. Now it's, and again, these line up observation by observation with the original data. If you screw up the order, you're in trouble. Okay, you've just now sort of said that square footage, that price square foot is now with a different rental unit. That's really bad news. Okay, any other questions? No, none? So things like is.na, okay, is your friend. You need that to actually look for to identify the missing values. Then you're just going to go off and subset. Life is good. So one of the things about this data, one of the reasons I pulled this is you're all living somewhere near here, hopefully, okay? And so how are you getting a good deal on what you're renting? Okay, what is and how much would you expect to rent to pay for a rental unit? Well, we know that there's certain things like where it's located that we can maybe explore that, but things like how many bedrooms it has, how many bathrooms it has, of course, which is related to square foot, okay, as well, because you can only fit so many bedrooms into 10 square feet, okay, but so you kind of think that the price would be somewhat related to the square foot, and then maybe number of bathrooms, bedrooms, location, let's say. There's all these different things. And then, of course, the actual type is complicated. So how do we look at this? Various ways to look at this. Okay? What do you want to do? So you can just look, well, here's the simple way to look at it. Davis, price, square foot, bedroom, bath. Let's just leave it at that. Got it? Anyone see a relationship? Okay, not so much.
Sorry, is there a way to keep the code up longer as soon as it hit?
Please, yes, just yeah. I'll save this and I'll give you all the code from this at the end. But yes, please just ask me to see this again. What are we doing here? We got Davis. We say, I want all the rows, but I want just these columns. This is the subsetting, okay, that we talked about yesterday. And again, quickly, and you know, we went through a lot yesterday, but it's the same thing over and over and over again, okay, because that's what we do all the time. Okay, we just basically said, I'm using the subsetting by name. And here I'm using the empty subsetting. I got this. They flow by. I put names on these things for my own benefit. I'm going to get rid of these. Row names of Davis equals null. I'm going to say just kill them off, please. And this will actually print differently now. So now I don't have as much text flying by on the left-hand side. So now it becomes obvious what the relationship is between all of these. I'm kidding. You can't see a relationship between here because they're not in order. Because there's four variables, and we're trying to say, how does price relate to all of these things? Well, you know, these are about the same, and they're about the same price. Okay, so we can look at bedrooms and bathrooms. Okay, they're all approximately the same. This one is slightly cheaper per square foot. We could look at price per square foot for the same thing. This one goes up, so it looks like if an extra bathroom costs you, an extra bedroom, should I say, cost you $250 or whatever it is. Okay, fine. But these are only just 3 observations. What happens across 175? And by the way, if you take a look at the web page for this, the DSI, you see our intro 18, that one. I put up all 11,000 that you can peruse over the last month, where I scraped it at sort of every week or so. Okay, so you can actually go and sort of look at a much bigger data set to see how the relationship holds. But how are you going to actually say, yep, more square foot means more price, and how much more price?
Plot it.
I'm going to plot it. Okay, now a little bit more specifically than plot it, because there's a lot of different plot types, and then how. And making plots, how many of you, I always ask this question, how many of you have ever taken a class whose topic is data visualization? Yeah, I didn't think so. Not a single person. And yet this is what we spend all our time doing, and it's seriously hard, okay? As I like to say, a plot, you know, they say a picture is worth 1,000 words, and I always ask you, how long does it take you to write and carefully edit a 1,000-word essay or document? Days. And yet plots, 2 seconds. I'll just take the default out of the software and off we go. Okay, and yet there's so much information, and they're seriously hard to actually to comprehend. So you actually have to put work in to actually explain what the focus is. So we have to compose a plot. But what sort of plot will we use for this? Okay, we could just, I mean, we can look at price. Okay, so we talked about this yesterday. Okay, and again, I'm going to have fun with this. We can say we can see a histogram of Davis dollar price. Okay, and where is this gone? That's now that's our histogram. So we can see a distribution. So what else do I want to do? Oh, come on. This is the easy part. You can dream up any plot you like. I'm not going to do it, but you can dream up any plot. What do you want to do? One of the hardest things to do when you're programming is if you don't know what you're trying to do, you can't get there. Okay? You can waste a lot of time just typing random stuff and go, oh, that's a nice plot. Pity it's got nothing to do with what I wanted. You're going to have to decide what you want to do. So what do you want to do?
Scatter plot
Of
price to square foot.
Okay, so we can now we go back over here, and again, this is what we call base graphics. Okay, so now we're going to put Davis and square foot. Okay, and that's what we get. So what do we think? So there's lots of ways to plot this data. This is kind of the question I'm getting at. This is your square foot. Now, okay, I don't like this Davis dollar square foot and all this. Let's actually go in, beef it up a little bit, okay? Which is, let's say the label on the x-axis or the horizontal axis should be square foot. We can put something in, and the y-axis, the y label should be price. And I'm going to assume monthly price, but that may not be true, but let's just assume, but we check this. And we may even actually put in a title, a main. Okay, we can say main equals relationship between.
A slash over there, is that going to be okay?
It is, but that's because I'm typing in a weird editor where it just says, oh, this line continues on. But thank you very much. Please yell whenever it's good, because I get slashes in there when I don't mean them. Right between price, between rental price, and again, rental price and size. Okay, and now we have a nicer plot. Okay, still not a very nice plot, but a plot, a good enough plot. But it's really important to actually put labels on these. Okay, obviously, when you're doing this just to actually explore something, it doesn't really matter because it's only for your own consumption. And in 2 seconds, you can remember what the data are, what the variables mean. But it is really useful. But then the second you're actually going to show this to somebody else, you better start actually putting real labels on it, possibly units that says this is in dollars, this is in square feet, because again, you would never hand somebody a piece of paper that says, here's some random notes I took. There you go. You figure out what I meant. So likewise with the plot. And it's not very hard to actually make these plots. Okay. So this is just plot. Here's the X, here's the Y, and here we get to dress up and annotate this thing with X lab, Y lab, okay, the main. We might even say, you know what, I don't really like those circles. I'm going to actually change the plotting character to be plus. I'm going to change the character expansion. Okay, don't ask why these are named this way, okay? Character expansion is 3 because I want it to be bigger, and I'd like them all to be red, please. Okay? Okay, okay. So I can change a lot of characteristics about the plot. This says I want, again, what is actually happening. I'm just telling you this because we're going to talk about something similar soon. Okay, what I'm basically saying is these get recycled. We mentioned this yesterday, but again, I can never say, you know, that I was going quickly. This is a vector of 175 observations. This should be a vector of 175 observations. It gets recycled to actually match up. So we could actually put in 175 different values. That's what we were doing when we were subsetting by the factor to change the plotting character or to change the color. We were actually sort of saying change the color of each point in the scatter plot based on some other variable. But in this case, we're saying, no, I want them all to be red. Okay, so this is easy. What do we see here, by the way? What do you see? Come on, what do you see? It's what you know. It's just confirming what you know. The bigger the square footage, the more you pay, okay? It's kind of, although when you get a really big house, okay, or a big place, it's not as obvious as you go up in the smaller region, it goes up, okay? What else would you like to look at here? What else do you think explains this? I mean, I kind of mentioned what other things, we only got to look at 2 things.
Add more access to it, bedrooms and bathrooms.
Add more axes?
Yeah.
How do you add more axes to it? You want a 3-dimensional plot and a 4-dimensional plot? You're going to get a 4-dimensional plot. I want to see the 4-dimensional plot. That one I'll pay money for. How do I add axes? You said over here. We don't want to do it over here because each point has to map back onto on something. So one of the things I could do, as we did, is I could change the color of this, or I could change the plot type, the actual plotting character for to indicate the number of bedrooms. And I could actually sort of say, okay, then I could also maybe change the size to be the number of bathrooms. Okay, and what about the type of this? What do you think? Is this an apartment? Okay. So remember the type variable actually has different, we have different types. So we have table, let's just take a quick look at a Davis dollar type. Okay, so we do have a lot of apartments, but we also have a few townhouses, we have a few houses. Okay, so maybe they're the ones that are big, okay? We could just kind of check this, what's the summary? Again, it's so easy in some regards. What do I want to do? I want to look at the square footage for all of the ones for the house. Is that clear? I'm just basically saying, hey, I just quickly want to ask, what about the square footage? What's the distribution of the square footage for only the ones that are for houses? Okay, for type, where type is equal to house. Okay, and I see it's 1,000, and it goes all the way up to 3,500 square feet. Got 20 NAs. There's the mean. So maybe maybe these ones over here are more houses. So therefore, in which case, maybe the relationship between square foot and price changes if you're a house, not just if it's the size of the actual. So how would you want to check that? I want to add more labels. I want to add more axes. I need to look at more conditions, essentially. I need to look at them simultaneously. Yes?
You just make them a different subset, different color.
I can make them a different color. Okay, so so we can do something like the following. Okay, and remember what we were doing. Okay, so let's go back over here and just change the color. Oh boy. I hate colors. Okay, because now colors are hard. Who here is colorblind? There's always somebody in the room. I know there's somebody colorblind there. Okay, so picking the colors is really hard, especially on my machine versus that machine. So there are ways to pick colors carefully. There's an R package called R Color Brewer that you can install, and then you can actually pull palettes for different purposes that actually show continuity changes as values increase along a continuous range, or you can actually have categorical palettes that actually try to make sharp distinctions between different categories or groups. So we can change this, and then we also have to handle color blindness and so forth. And you get to pick a lot of these things. But okay, so let's go over here and okay. One of the things we can actually do, which is slightly well, we'll just do this for the time being. Okay, this answers a slightly different question. Okay, and I want you to be thinking about it. Okay, about how do we actually ask the question that we want? This is for bedrooms. Okay, so we were just looking at square footage completely independent of bedrooms. So rather than making a complicated plot that actually has colors and plotting characters that indicate the number of bedrooms and the type and so forth, we could look at them just 2 variables at a time. Okay, now this is the number of, we could actually just do a scatter plot of the number of bedrooms against the price. And I notice I have no labels on these axes at all, which is not good. Okay, is that price? I hope so. Or is it square foot? I don't know. Okay, so you kind of, this is bad news. Okay, yeah, it happens to be price, but we have no idea. So what's this telling us? This is the number of bedrooms. I'll tell you that because I didn't put a label on it. How would we put a label on it? It's the same old approach. XLab equals number of bedrooms, and YLab is equal to price. And we can put a title on it. And now it's self-describing. This is good. What's this telling us?
More bedrooms is more money.
That's not true.
Sort of.
Sort of. I like the sort of business. So it means more bedrooms, more money, and it's related to square footage as well. So we got to take account of that. What the heck's going on here?
Studios.
These are studios, probably, but now we can actually go and take a look and sort of see. Okay, again, we can take a look and say, hey, let's look at Davis dollar type, such that Davis dollar bedrooms is equal to 0. Okay, and let's just do a table of this. Okay, and we've got 2 apartments that are studios. Okay, and we got nothing else in this category. So there's only 2 studios in this thing. So that's kind of weird. Okay, so we don't. This is a box, but it's only got 2 observations. So it's helpful to be able to actually just ask these questions. You're all comfortable doing this? No? Yes? Okay. What else do we want to watch? Or what else do we want to look at? So box plots are really helpful. This is actually showing us the distribution, okay, conditional on each number of bedrooms. So we subset on the number of bedrooms being 1, and then we look at all the prices, okay, and we can see this in a box plot. What are these lines here? Pardon? Close. They're the medians, okay? So how do you know? I don't know. This is how a box plot is defined, is that this is the median, this is the 75th and 25th quantile, and these are little, these are regions beyond which we would get outliers, and it's kind of weird, but they're very helpful. This allows us to see, oh, hang on, this is kind of handy. This is actually allowing us essentially to see density plots, okay, for each, by splitting on the bedrooms. Okay, you subset each of the each number of bedrooms. You look at the price for that subset. By the way, so this is just the same thing as this, which is if I wanted to compute the median, it's T apply because I want to group by. So Davis dollar price, Davis dollar bedrooms. Okay, and then I want to compute the median, and lo and behold, that gave us. That command is just saying group subset this thing based on the unique values of this. So we get the 0 to 6 different bedrooms numbers. Okay, so we have 6 different groups, and then just compute the median of this vector of this for each subset. Everyone happy?
How would you get rid of the 0 bedrooms in the plot in the call for the plot?
Okay, how do we get rid of the 0 bedrooms in the plot? Well, this is what we have. We want to get rid of this. Okay, good question. How do we get rid of this? How do we get rid of the zeros? We don't want, suppose we just don't care about this. This is goofy. Pardon? We can move it over to the side. Just slide it off, okay? But aside from that, how do we get rid of it? So this is the game, same game we're playing, okay?
Create a new variable and remove the bedrooms.
So all I do is just subset, okay? So I can go back here and say Davis dollar Davis. Give me all the things in Davis such that Davis dollar, what is it? Bedroom equals 0, that guy. Okay, so I'm subsetting, okay? But that's not the guy I want. It's everything other than that, okay? So I can put in not equal to 0. Okay, and now I get this. So let's call this D0. Okay, DN0. So what's the dimension of this? it's 173. That got rid of our 2. Yep.
What is the not sign?
The not means not equal to, okay? This, what, which this is the exclamation mark? Sorry, okay, sorry, yes. So not equal, okay? I could have just said equals and put the not in front of the whole thing, okay? You can, all I'm going to do is just say it's the opposite of that. And now I've got this thing, and now we can go back in and we can go and say, go and draw this. And now I'll put in, I have to change all of the references to Davis to being my new data set. And that's kind of annoying. It's only 2, thank goodness. And lo and behold, the 0's gone. Okay, so we can subset and only look at those things that we want. We could also even just sort of say, okay, show me the groups or the distributions where we have at least 5 types or 5 observations in each number of bedrooms, okay, or whatever it is. Okay, what else do I want to do? Okay, yep.
What was the difference between T-apply and S-apply?
Yes, S-apply. S-apply is the simple, okay, S-apply just walks through an ordered collection and applies a function to each element. T-apply is for table apply. It groups first and makes subsets. Okay, so in this case with the T-apply up here, we're saying there's 6 unique values for bedroom, 0, 1, 2, 3, 4, 5, 6. Split, okay, split the price vector based on the corresponding number of bedrooms. Okay, so I will do a split first, end up with 6 different blocks. Okay, so I'll end up with this, okay, and with this, and then what's 4, 5, and 6. Okay, this is for bedroom 0, 1, 2, 3, 4, 5, and I'm gonna, okay, that's fine, whatever it is, however many we have. Okay, now this is what we've done is these are all the price values. Okay, we got price in everywhere for those observations that correspond to, so in the first one, all the 2 observations corresponding to the bedroom being equal to 0 are now in the leftmost bucket, and so forth and so forth. And then now what we do, okay, now what we do is we call median, or what did I say? Yeah, median on this group, median on this group, median on this group, and median on this group. Okay, so the T-apply first splits everything, and then it goes through each subgroup and applies the function. Okay, so this is so T-apply is the same as split into the different blocks, okay, and then an S-apply over these blocks with the function, okay, which is the median. Okay, so S-apply we say S-apply over each element and call median. That's S-apply. It just says do the same thing to each group, okay, or each element. Whereas T-apply says before you do the S-apply, group them first. Does that make sense? Okay, so you can do an awful lot of plotting in R with using things like box plot and histogram and plot density and you name it, okay? You can draw everything you've ever wanted to draw, okay, and more. You have a lot of control over this. Part of it is there's a bunch of individual functions. They all work approximately the same way. They take the same arguments, okay? They have a data, you give it the data, okay? And you tell it, and so the argument, here's the data I want to plot. And this says, here's your Y, here's your X, okay? And they even take it in different forms. If I said box plot of Davis bedrooms, it would just draw one box plot. Because I do it this way, it's actually saying group by bedrooms and then draw a distribution of price. If I'd done it the other way around with commas, it would actually do the same thing. So it takes data, it takes the description in various forms of the data. But the box plot here, this is the verb that basically says I want a box plot. In the other case, I wanted a plot, a scatter plot. In the other case, I wanted a histogram. So there's a variety of different plots that you can construct. There's another way of drawing plots. It's actually an awful lot of people are using it and they like it. It's I think it's slightly harder to learn, and then it's easier to use to do a lot of different things. But you can do everything in several. We have 3 different plotting engines or models in R. Pick whichever one you want. There's some nice benefits to using Ggplot, okay? Because if nothing else, it gives you legends very, very easily. One of the things is we're dealing here with data are in our data frames. If all your data are in data frames, life is good, okay? Ggplot requires everything to be in a data frame, so you actually have to augment your data frame with extra variables and so forth, but that's fine. Then you get a certain sort of uniformity, and that's fine. There's a learning curve to Ggplot, but there's a principle to it that comes from a book by Lee Wilkinson called The Grammar of Graphics. And it's very simple, it's very obvious. When you make a plot of data, we're only talking about data plots, okay, data analysis plots. We're not talking about how you make video games. We're not talking about how you do ray tracing. We're not talking about how you do all sorts of CGI and stuff like that. We're talking about visualizing data. Basically, here's what you do. There's a function called Ggplot, okay? The first thing you need to do is you need to say library of Ggplot2, okay? Why is it Ggplot2? Because the original Ggplot is now deprecated, okay? So this is the second incarnation of Ggplot, okay? Same principles, different sets of commands and functions and behavior, okay?
So I would mention that the older version is deprecated. That means that code that someone may have written with that version might not work with the correct package that came back. Affecting the paper that I was writing. So just keep that in mind when you're using Ggplot, that it is changing. It's not like base R that's static on purpose, right? So find the resources by the page, connect for yourself if you're going to go.
So Ggplot is your command, okay? So there's a principle to this, okay? You create a plot, and you tell it what data you're going to use, okay? Then it may be simpler to actually do this, okay? You basically have data inside in your data frame. You have variables, okay? What we're going to do is we're going to map these variables. Some of them, the ones of interest, not all of them. We're going to map those into an aesthetic. Okay, that's going to actually, okay, and then, so this is going to, and then we're going to map these into a geometry, okay, and that's going to give us our plot. Okay, so a geometry is going to give us points, but we actually have to put them, we have to say what variables go with a certain set of, with points, and so we're mapping them into X and Y's, or we're mapping them into the size of a point, or we're mapping them into bars in a bar chart, if you ever want to create a bar chart. No, you never want to create a bar chart. Okay, never create a bar chart. Okay, okay, but so we're going to map the data to something that appears on the, that is a variable in our plot that then gets mapped and rendered as actually an element on the plot itself, which are points. So this allows us to deal with certain things in a very uniform manner, okay? So we can change, okay? So we can take a plot, make it an XY plot, but then actually by changing the scales, we can actually use polar coordinates or something like that and actually get things plotting on a circle or so and so forth. So there is actually a principle behind this. As say Lee Wilkinson just wrote down a bunch of stuff 15, 20 years ago that said, you know, this is a better way of thinking about making plots rather than ad hoc stuff. It's the same plots. It's exactly the same plots we've been drawing for the last 50 years. It's just a different way of actually thinking about them. Sometimes it works and makes certain things easier. Sometimes it doesn't. But what we're going to do is basically start with data. We're going to create a plot, and then we're going to put layers on the plot. And every layer that we create will have a mapping of the variables to these things that we want to plot. You can think about them as being in a scatter plot, it's the X variable, the Y variable. That may be all we need for a scatter plot, okay? You might think about it as being, for a bar chart, they might be counts. You're actually taking the data and moving them to counts, which is the height of the, of each bar, in which case we're going to do a transformation. We're going to do some statistical summary to actually get the values that we want to map the data to the aesthetic. And then we're going to actually draw them and map them to bars. Okay, so there's these geoms. Okay, geometries are they're called geoms. Okay, so this is basically the pieces you have: data, an aesthetic, a geom. Hopefully the scales we don't have to specify, but we can. Okay, hopefully we don't have to specify any statistical summaries, but we can. Okay, and then the last bit we'll talk about later on. This is not necessary at the moment. Okay, so here's one of the things we can do in Ggplot with box plots. Okay. Okay, it thinks for a while. It gives us a warning message that it removed 12 rows containing NAs. Okay, and then let's go back over and look and see what it actually got. What's the difference between what we had before? Background. Okay, the back, which you can actually only just, it's got grid lines, so it appears differently. Okay, but it's the same information, but that's fine. Okay. So it gives us basically the same thing. It doesn't actually put the labels are actually slightly different. Okay, so it doesn't show us 1 and 5, which is good and bad. Now we can discuss the aesthetics. Okay, now you can't go and change the X labels in the same way we did before, which is just in the as arguments to box plot. We said X lab and Y lab and the main and all that stuff. You can't do that. You can't do that in Ggplot because it's an extra layer. You actually construct it as an extra layer. So down here, we're actually sort of saying, here, I'd like to change the label on the horizontal axis. So let me call the xlab function. So then we're replacing we're replacing this argument to a function with a layer down here with a similar name. You have to learn a different set of things. It's kind of annoying when you go between the two. So a lot of people just do everything in Ggplot or everything in base graphics. Okay, so either one. Pick your poison. It's really nice if you can use both. Why? Because this is actually shorter than this. You don't have to think as much in some regards for doing very quick plots. For doing very rich plots, Ggplot gives you a different set of controls, which can be helpful. Okay, so what we're actually doing is this. Okay, what do we got? We're basically saying Ggplot. Here's my data. Everything I refer to, all the variables I'm going to refer to, are going to be in this data set. Okay. If we need to, we can bring in different data sets in different layers. But the nice thing is most plots, many plots, say, I've got one data set and all the layers I'm going to draw, like all the points and then a couple of lines or text that annotates every point, all of that text, all of the XY coordinates are in the same data set. So I'm going to specify it once. So here's the data, okay? And by the way, here's the aesthetics. Here's the mapping, and this when we talk about aesthetics, it's a mapping, okay, of a variable to a concept in the plot. And this one says basically, the aesthetic is this is your X, this is your Y. Oh, and by the way, I want to group by bedrooms. Okay, so bedrooms is on the horizontal axis, but I actually want to group this, and that's because I want to essentially draw my box plot for the groups with this subset, split it by bedrooms, and off we go. Everyone with me? Any questions? Just yell.
Should people have this installed?
If you want to play along, yep. Yeah. So installed packages. So if you don't have it installed, that's fine. You can do it later on if you want. But installed packages of Ggplot2 should go off, or you can point and click in our studio and over in the packages area. That should be enough to install it. It'll go off and find the latest version. It'll pull down a bunch of other dependent packages. And part of this is everything needs to be in a data frame. And that means any derived variables that you want to actually include have to get into a data frame in some way. So sometimes we don't want to plot the raw data. We actually want to do some statistical operations on it and then plot the results of that. You need to put these in a data frame. They need to be organized in a particular way. This is true of the base graphics too. You sometimes do a lot of work to actually get the data that you want to plot, not the raw data. But because the data frame is so critical to ggplot, there's a bunch of packages that try to actually aid you in making these data frames, things like dplyr and so forth, so that you'll pull down a bunch of other packages for this, and you'll have to go off and learn dplyr and all these different things. You can do, in my belief is that you can do everything you want in base R. Okay, this is a different way of doing the same things. Just pick your poison. Okay, they're both equally annoying. Okay, yep.
Can you say best practices as far as when you have an R script and you're putting in, a series of libraries, packages, running for both to pass on to other people?
Yep.
And also like when it's certain commands are broken, you add one script and contains a command. It's called by another. One library that contains a command is called by another library, and it breaks it.
I don't know how. So one of the
like I forget what the word is, but like sometimes you load ggplot and you've got another library there. It's got the same function.
Okay, thank you. Yep, there's the masking involved. Yes, thank you. Yep. So this is an aside. It's a good thing. Again, if for what we're talking about now, this is the least of your worries, which you're trying to actually get R to do something. You're not thinking about sharing it with anybody else. So let's just focus on it. Why? But there is a reason why you want to share it with somebody else, and that is because you want help. He says, hey, I've got this far. It's broken. Now, if you send it, if I'm standing around, or you come to office hours in the DSI or whatever, you bring your laptop and we can play with your laptop and it's all there. The file need never leave your machine. But if there is, if you want to send it to me, then you better actually help me make it work. So one of the things we actually do is, what is this? We basically say in your script, you'll sort of say, read RDS from a URL of HTTP, okay, or whatever it is. And again, one of the things, this is a very good thing to do, which is, I can't get the data. If you send me the code and I don't have the data, I can't help you because, we're just like, that's nice. I mean, maybe I can read your code and try to guess, but I don't even know what variables you have. So you better be able to give me the data. You better be able to do it in such a way that it's local, where we actually just say read.csv of my file. Okay. Okay. And so my file.csv. Or whatever it is, and that should be in the same directory that you send to me in some way. So as opposed to C:users, okay, or whatever it is, where I have to change this. So either way, however we get our data, and what we tend to do is at the very top we say these are the packages I need. So we list these at the top. It helps if they're listed at the top, not when we use them. It makes more sense to load them when you use them, but then I can't see them. So it's easier to do it this way. What you can do is this library of ggplot2. If you want, okay, now there's an issue here, which is this will fail if ggplot is not installed. Okay, now if you're going to be really nice if you're if you're going to be nice, okay, that's great. This just says it's an error, and I look at it and go, okay, I see what the problem is. Do I want to install ggplot2? Alternatively, I do see people write this, okay, which is ggplot2. Okay, these are almost synonyms, but they're not. This says go load ggplot2. And by the way, if you fail, just keep going, which is really bad news because I'm going to fail way down deep in the script. So this is bad. Okay, so this is bad. Don't use this. Okay, what you can do if you really want, you can say if that's false, if that fails, then why don't you just go and install ggplot2? Okay, now that's a handy little thing to actually do because that says, okay, this script will rescue itself. Okay, this script will actually ensure that the right things happen. Okay, and this is an if statement that says, check this condition. If it turns out to be true, which means that we failed in loading ggplot2, then I want you to run this command. Okay, and this is a useful thing to do. Okay, now it's annoying because you're now potentially just changing my machine. Okay, but let's assume that that's okay. So this is a good practice. okay? Or at least having all the libraries at the top. And then as for masking, so if we actually do this, let me go over here and say G. Here's R, and here's library of Ggplot 2. Library of dplyr, let's just do that. Where are we getting? And now the problem with library of dplyr is it says, by the way, dplyr is a package that we just loaded, okay? And it defines filter and lag, which are also in the stats package. Now that's a problem because when I now type filter, it says I got it from dplyr, and I go like, hang on a second, I didn't want the one in dplyr, I wanted the one in the stats package. So what's the best practice for doing this? In my code, where did I just, okay, if, you know, I might do library of dplyr, or I do the if require of dplyr, install dplyr, whatever it is. In this case, Ggplot 2 will install dplyr, so I got the dependent, I don't need to do this. But if I do this, now if I actually want to get the, suppose now I want to actually compute the filter command, filter of X, of $x, okay, whatever it is, okay? If I wanted to do this, it will pick the wrong filter. It'll pick the one from dplyr, and that may not be what I wanted, okay? And just for completeness,
What's the purpose of your filter?
filter, I'm just using this as a random example, but filter is actually in dplyr, filter will actually is an equivalent to subsetting. You can basically say filter based on this condition. In the stats package, filter is actually doing some sort of time series filtering, I believe. I can't remember. We could look it up. But this is what's actually happening. When we type library or require, it added this package to our search path. Okay. So if I do, let's load another package. Let's load. I'm going to just load the XML package. Okay, now look what happened. The XML got shoved in just in front. Now, when R tries to find something, so this is why I was hesitating to talk about this yesterday, but when I talk about something like boxplot, okay, of Davis $bedroom, what R does is it says, let's go find boxplot. This is a call to boxplot. Where's boxplot? I have no idea. So R says, are you here? No. Are you here? No. Are you here? And it keeps going until it finds a function whose name is boxplot. And then it says, okay, now I'm going to call that. And then it starts processing the arguments and passing them to boxplot. Okay. But now if I call filter, it says, hey, filter, are you here? No. Are you here? No. Are you here? Yes. Okay. So as we load packages through the library command, we're changing our search path. And that changes how we find variables, okay? And that means everything can change. A lot of times people will send me something and say, this doesn't work, and I run it on my machine, it does work fine. It's like, oh, I say, do you happen to define a function called filter in your global environment? They go, oh yeah, I did, but that shouldn't matter. And you go, yeah, it does matter. We're using totally different code. So what we need to do is actually say, use the one in the stats package, wherever the stats package is. Is there stats there? Yeah, there it is. Okay, so here's what we actually do. Filter just goes off and searches, bing, 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 finds the one in dplyr. But I want the one in stats. And now I get the one in stats, okay? And how did I do it? With this command, which says, here's the function, here's the name of the function I want, but I'm going to tell you in which package to find it, which is stats : filter. Okay, the 2 colons says, I'm in charge here. I'm not letting you look this up because I need to be very specific about this. Make sense? Yes?
Which filter?
And what you can do if you want, you can say is find filter. And it says, there you go, this is where I found them. There's 2 of them in your search path. And they're in this order. So that's how you can reason about this thing. Everyone happy? Okay, your script, if your script goes off and does something like ggplot of D, and then it starts making a plot, okay, John point, we'll talk about that in a second, okay. If you do this and you haven't loaded, if you type it correctly, if you haven't loaded this, If you haven't said library of Ggplot, that script does not work because you're just taking a chance that I may have Ggplot 2 loaded into my session. So you have to say, I need you to load these packages. Now I can use the functions inside them. Happy? Okay, so it's a good idea just to actually be clear about what the requirements are. I get a lot of people sending me code and they go like, hang on a second, I have to go figure out what packages your functions are in. This is your job, not mine. Okay, and that's not as portable. Okay. Okay, so what are we doing? Switching back to Ggplot. Okay, what we've got is we got a plot. We gave it some data. Well, then we map these aesthetics that says this is the X, this is the Y, and by the way, here's an extra thing which we're using to group the observations by. Okay, so this will essentially do the t-apply, the splitting. Okay, and that's fine. And then we basically say we've mapped the data and the variables to these aesthetics, the X and the Y. And now I want to actually render them in a particular way. And this is the geometry that we have, says we want a box plot. Okay, and off we go. Okay, and if we wanted to, okay, so where was I? Okay, if we wanted to, so that produced this plot. And one of the motivations behind the grammar of graphics, okay, is by just changing the geometry, we get a totally different plot. Okay, see this plot? And the previous one was a box plot. The only difference was exactly the same code that sets up all the mappings of the variables to these aesthetics. The only change was how we render them on the geometry. Does that make sense? So in some regards, this is simpler in some ways than having to say, oh, box plot of these variables and scatter plot or plot of these variables. It's almost the same, we just change the geometry, but the setup is the same. Okay? And down here, okay, so as I say, there's a lot of controls that you actually want. Okay, so what we're actually going to look at here is we change the X labels, okay? There's a bunch of stuff. There's several books on Ggplot. There's an R graphics cookbook that you can look up. As we say, as Pamela mentioned, Stack Overflow is your friend. Googling stuff, you will find a whole lot of different things. As long as you kind of have a basic understanding of this notion of, I set up the data, I map the aesthetics, which are the variables, to the actual X, Y, size, and so forth. Okay, the different characteristics of the observations in the plots. And then I construct a geometry. Okay? So we're going to do the following now, okay? What I want to do is this. I want to actually create a plot. And okay, you'll see that I've changed things very slightly, but I can do it either way, but it shows a slightly different feature. I'm going to create a plot that has Davis as my data. Okay, it just locks that down. If I stop here, it will not produce a plot. It's just because there's no rendering, there's no geometry, there's no mapping of any variables to any aesthetic. Okay, it just says, you got a plot. And it actually turns out to be quite useful because you can basically make a plot that doesn't draw anything, but has all the information encoded, and then you can reuse that plot in different ways. We'll see that in a few minutes, okay? But basically say, okay, here's Ggplot is the function that sets up the plot, that basically initializes a plot with some data. Almost invariably, we say, here's the data that in which you will find all the variables. Then we basically come along and say, okay, I want to draw a scatter plot, because that's the point. I want a point plot or a scatter plot. And here's the X variable, here's the Y variable. And by the way, I'd like you to change the plotting character based on the value of bath. Remember, bath is 1, 2, 3, 4, or whatever it is, okay? Okay, so that I basically start saying, if the bath has a value of 1, I want you to plot it using a plus. If the value of bath is 2, I want you to use a circle. If value of bath is 3, I want you to use a triangle. So we'll actually be able to see that encoded in the plotting character. These are mapping. There's 175 values for bedrooms, 175 values for price. We're mapping bedrooms to the X to the X coordinate, price to the Y coordinate, and then we're mapping bath to the shape aesthetic. Okay, is this clear? It wasn't clear to me the first time I read it. Okay, it's like, okay, what the heck is an aesthetic? Okay, but because it's not what we see on the screen, it is actually the characteristic in the plot. So this is, before we render anything, we have a shape, okay? Then we will render it in that particular way, but we're mapping these variables, okay? And notice, by the way, I don't have to say Davis dollar bedrooms or Davis dollar price. It's just, I just use the variable names and it will find them over here in the data set that I locked into the plot, the Ggplot. Is this clear? Yell any questions you have, okay? So you might have noticed that I have a little comment at the end here that this fails miserably, okay? Does anyone know why? I'm showing you the code below, so hey, again, I stop dead when I get an error. I see everything that's happening. This is what's happening I call things and it's printing a Ggplot, it's building a Ggplot. These are all the activities. The error happens. The error happens way down here. Oh my God, I'm thoroughly lost. I didn't write this code. I'm thoroughly lost. How the heck do we debug this? I don't know. But we look at the error message. A continuous variable cannot be mapped to shape. So what should I do? Discontinue the variable. You're out of here. I like that. The gun. Go away variable. What do I need to do? And again, part of this is when you're using R, when you've got a lot of experience in R, you can probably write a command and you get an answer and it's done. Okay, you'd probably make a mistake, a few typos here or there. Okay, you get a syntax error, then you get an error because you actually had a thinko and you just typed the wrong thing. You need to be able to recover. Okay, and the first couple of months that you're using R will be incredibly frustrating, okay? Because it's just like, oh my God, every single thing I do is an error and I cannot read the error messages and make any sense of them. Stack Overflow is your friend. Everyone else has run into the same problems you have and haven't. Hopefully somebody has actually written a coherent answer. So Stack Overflow is great. You need to but there's an art to reading Stack Overflow. There's an art to actually looking through 25 answers and going, I know which one it is that actually is relevant. Stack Overflow tries to rank them, but sometimes it gets the ranking wrong. So what should we do here? This is problem solving, which unfortunately is not, this is debugging and problem solving, which is not written down in many books.
Can you not use a shape?
I want the shape. I want a plot. I mean, let's just not make a plot at all. Let's just go home. Okay, I mean, I wanted a plot. Okay, and again, I'll show you. What we actually wanted is a plot that looks like this, which is what we wanted was a plot. What did we actually say here? We said bedrooms is here. Bedrooms, and we have price over here, and we then have plotting characters here, okay, and triangles, and this is what I wanted, because I wanted to see the number of baths. I don't know why, but I want to see the number of baths. There may be many ways to plot this, but remember, we basically said that there's the square foot, there's the price, okay, there's the number of bedrooms, and there's the number of baths you have. There's the latitude and longitude. I want to look at this data and try to understand how much should I be paying for a house or an apartment or whatever it is. So we've also got the type here. Oh my goodness, there's a lot of data. There's a lot of variables here, and I need to look at this. It would be great if we could draw a 5-dimensional plot. It's hard, seriously hard to look at a 5-dimensional plot. But you can get 2 dimensions this way. If you wanted to, you can get 3 dimensions, but it doesn't work very well on a 2-dimensional screen. But we get an extra dimension this way. That's 3 dimensions. Even if we take this one away, there's 3 dimensions, okay? We've got the bedrooms, the price, and we've got the plotting characters that indicates the number of baths. And if we change the color over here as well, we could actually get the bedrooms in potentially. Okay, so how are we going to get how can I get 5 dimensions? How about if I actually put in the square foot? Okay, so how do we've got color was I said for type. Okay, this one here for the plotting character, the actual glyph or character that we use is for the bath. So that would be bath and type. We've got the number of bedrooms is there. We've got the price is here. All I need is the square foot. Anyone tell me how I can get my fifth dimension? Size. I can change the size. Okay, so I'm going to make this big because it's got a lot of square feet. Okay, 5-dimensional plot, no problem. I throw down 11,000 points like this and your head will explode and all you'll see is a big mess, okay? But, so now we may want to think about something slightly different. Is there another way of getting 5-dimensional plot with that? Is there another way of doing a 5-dimensional plot showing all the data for 5 variables, but I'm going to only have 4 on a scatter plot? The answer is yes, it's very simple. Just be creative. So let's take away type here. Let's just take away type. Okay, and we'll just say let's just do it for home for a house. Okay, so I just subset and do it for a house. Now what about an apartment? Well, I just subset and do it for an apartment. So what I can do is I can actually have. So this is for house. This is for apartment. This is for a townhouse. This is for a loft, and so forth. And if I have 4 dimensions on each of these, I get 5 dimensions in total. Okay, so I can layer everything onto one plot with many layers, or I can have what are called facets, okay, or panels, okay, and where I subdivide them just like we did over here, and I draw separate plots. Everyone happy? That's the goal. So I want to see these things. I can't give up shape here because I want to get to 5 dimensions, not down back, and I want to go backwards to 2. So the problem with this is it's a continuous variable. What's a continuous variable? Non-discrete. It's nominally, it's supposed to take on potentially values between any value between 0, between a minimum and a maximum. Bath is not. So let's take a look at this. Class of Davis dollar, but this is why I like to know how I can actually find these things. What's the class of this? It's an integer. That's not continuous. It cannot take on a value of 1.5 because I told it it couldn't. But Ggplot says it could be from -infinity to +infinity. That's continuous in my mind. So what will we do? I need to make that into a categorical variable. So how will I make it in? Because I need a plotting character. I need a plotting character for shape, which is an X, let's say, corresponds to one category, a plus corresponds to a different category. I need to map these into categories, not into real valued numbers. Okay, because I can't map this thing and then half an X or 3/4 of an X. I need to actually make them into categories. How do I make something into a category? What is a categorical variable in R? Remember we came across them yesterday? There was a reason. What was the name of them? We had them in our data set. So let's go see if we can remember what the name of it is. I'm going to loop over. I'm going to, for each element, for each column, I'm going to call the class. I'm going to get the class name, and then we'll see if we can recognize it. So what was it? Factor. Okay, this is a very handy thing. I can't remember the name of the stupid thing. Well, let's just ask. I know there's one in the Davis data frame, so let's just ask what are the classes of each of this thing. This just loops over all the columns and calls class on each of it. So I get the. You could look in the str, the output of str for some. Somebody said that is a little overwhelming. Okay, we just ask a more specific question. We want a factor. Okay, so one of the things we can actually do. Let's go back over here and say, hey, what if I try to make this into a factor? Now it says, sure, I'll go along with that. And lo and behold, we get our plot, okay? And now what's a plus over here? So we see this is the number of bedrooms. Here are the 2 observations corresponding to our studio or what we think is a studio. And the plus means, oh, that's not good. That's not good. Okay, the plot is good, the data are not. Okay, this says a plus with 0 bedrooms and the price is 2,500. And how many baths does it have? 5. Okay. If this is correct, okay, so it may be a 1.5 bath, it may be a half bath, I have no idea. Okay, this is probably an error. So we've already found some dubious data here that we want to go back and check. Okay, we could have found it through the commands that we were doing earlier today, but a plot is way easier to look at than actually, because it may suggest things we don't know about. Number of bedrooms. Where do we get 5 baths? Look, there's 5 baths. That's not too bad, but there's more baths than there are bedrooms. Okay, lots more baths than there are bedrooms. Okay, even more baths than there are bedrooms. This is probably, the bath thing doesn't look like it was calculated correctly or reported correctly, but because there's so many of them, it's probably me who actually got it wrong. Okay, so now we do. Okay, so what are we going to do next? Okay, so all we did was actually change this to, hang on a second, is that what I typed? This is in my notes. This is what I typed up here. What the heck's the difference? You can't tell because you have to read the whole thing and compare them text by text by text. Okay, this is where it's actually be easier if we actually broke this up into 2 different pieces, but the difference is ordered versus factor. Okay, a factor makes a categorical variable, and ordered makes another categorical variable, but it actually says that the levels are ordered. For example, your grades, A, B, C, okay, they're ordered. They're not just categories, but A is better than B is better than C is better than D, okay? So sometimes we actually sort of say this person is young, middle-aged, older. There's an ordering to these things, but they're still categorical because we can't treat them as continuous variables, okay? So ordered or factor, it doesn't really matter too much in this particular case, okay? And now let's just do this. Okay, so we'll do the same sort of thing. What's this going to do? This just switches to using color rather than shape. Okay? Everyone with me? What's the difference? It's down here if you want to compare. This says I'm mapping bath to the shape aesthetic. This one says I have to make it a categorical variable. This one says I'm mapping color to this. So how am I going to get 4 dimensions? So suppose I want to show type as well. How do I change this so that I can map, so I can also show the type of the rental unit on the plot? And then we'll go for broke.
Levels. Shape levels.
Shape equals levels of type. Levels will just give me back the unique labels. Okay, I need 175 values rather than the 5 levels. Okay, the levels are important in a factor because they are the set of unique values. But then we actually need the observations in there that map to those values. So we need to group them essentially. So what's happening here is it's sort of going through and looking and sort of saying, oh, you've got 5 bathrooms, then you get a plus. You've got 2 bathrooms, you get a circle, and it just wanders its way through. So you see what I've got here? I've got a shape here. Shape equals bath, color equals bath. So what if I just mix these together by saying shape equals bath and color equals type? There's no, okay, so that should get us approximately where we want, I hope, he said. Okay, which is it. And again, we'll make it a factor of, what was the type? Oh, we don't need that, do we? Because what's the class of Davis dollar type? It's already a factor. So there's no need for us to actually do that. We just say, we don't say type, we say, what is it, shape equals type. And now, and this is one of the very nice things that Ggplot does for us, it just takes care of annoying legends. This is a pain to actually do. Okay, but now what we've actually got, we've got the plotting character is showing us the type of rental unit. We've got how many baths there are by the color, and now we can basically see. Notice, by the way, these are our houses, all houses which are corresponding to large square foot, which is no surprise, okay? But now we're actually seeing it. We are seeing there are some large things over here. So what are these circles? Sorry, not circles. What are these things? This is a duplex. This is a large duplex with several bedrooms, with 3 bedrooms and so forth. Okay, so now, is that plot okay? What would you change in that plot?
Scale.
The squidge?
Scale.
In what way would you change the scale?
Vertical expansion, so you can see individual points.
I'm going to run out of space. This is as big as I can make it. I mean, I could change this to be from 2,000 to 3,000. I could change the range, but then I'd miss all the other ones. This is a real pain to actually, to zoom in, which would be nice. I'm going to have to leave out a bunch of stuff, potentially, or probably.
Can you set points so they don't overlap with one another?
How would I do that? I could, because you see, these are discrete. Okay, this is, you have 2 bedrooms. Again, you can't have 1.9627 bedrooms, okay? So, we could actually just jitter these, okay? Just add random noise to these things, okay? And then that would actually allow us to sort of see them in a slightly different way, okay? So let's try to do this one. There is a function called jitter. There you go. Now there's another way to do this in Ggplot too. But here we're mixing regular R with Ggplot. But this makes sense. But you can't do this if this is a continuous variable where you're actually now going, see the value? It's now over there. Okay, and the other one is now over there. Okay, but they're the same value. Okay, that's not in the spirit of scatter plots. But now we actually do get to see a little bit of stuff that it makes it a little clearer. So rather than actually changing the scale here to see things, we're kind of just saying we're utilizing the fact that, everybody understands that this means that this has 1 bedroom. And if they look at here and they go like, okay, how come you have 1.2 bedrooms? You go like, yeah, it's just an artifact of the way we're actually trying to visualize the data. But, okay, but that better be clear to everyone. Now you actually have a little bit better. Anything else that you'd like to change?
What do you change to make it scatter?
Pardon?
What do you change to make it scatter?
Oh, sorry, there we go. I just added jitter the bedrooms. And there's another way to do this. There's 2 ways to do this in Ggplot where you can actually tell it to jitter the points, or you can actually tell it to, there's another thing called dodging, where you actually, things that would be on top of each other, they just they try to separate themselves, which is useful for bars and stuff like that. Again, it's a more general principle, but this is just what jitter of bedrooms actually does is you can actually look at it. If we actually look, so here rooms, let's look at the first 3. Okay, Davis dollar bedrooms. Again, I would love you to get really familiar with this. Davis bedrooms pulls out the bedrooms. 1 square bracket 1 through 3 just shows me the first 3. That's no fun. Okay, which is we'll just show that it actually gets them. Okay, so now there's the first 10, and then if I just do jitter of this, it just changes them. So we're actually changing what the values are, but they get thrown away. But just for the purposes of our computation, it just says, oh, compute a new variable which is jitter of bedrooms, and then use that when you're making the plot. Okay. Anything else you'd like to change? See, I'm the NA. What's wrong with the NA? I particularly like the fact that to see the NA, you just go and look at the gray one. Okay, so there's either a lot of NAs or there's, okay, so the NA we probably don't, it's not appearing, but it is a level in here. Okay, Ggplot treats it as a level. So, okay, and likewise with the ordered bath, in this case, it actually, you know, we can see where the NA for the bath is. What else would you like to change? See, this just bothers, yeah?
Could you change your way to spell the data or
Change this guy? Yeah, I would like to change this. We saw how to do that earlier, which is just called the xlab function. So yeah, let's tidy this up, okay? Let's tidy that up. Let's tidy this up potentially. And then this just bothers me. This is an artifact of the fact because we didn't have our data in the right format. So it should have been a factor, but so I did it in the command, but as a result, poor Ggplot doesn't have a name for it. So it says, I'll just use the name of the command you use, order to bath. So we can tidy up this. Again, when you're cleaning data, when you're examining, just checking to see, is this just sane? Did I read the data incorrectly? You don't care about any of the cosmetic niceties, okay? The second you're going to sort of show this to somebody else, you might as well clean it up. Okay, so in this case, we can go down and we can say, okay, we could change the xlab using xlab, but we can also basically go down and say, hey, change the labels. And where we said color, I want you to use baths, okay? And when we said shape, I want you to use some other string, okay? And otherwise, Ggplot will just sort of it'll fill in the defaults very kindly of it. Okay, so if we this is a slightly different plot, but it's a similar plot. Okay, this goes back to the old one. Now you see we got baths in here rather than ordered bath. Okay, and likewise we could change the xlab down here. Go ahead and play with it. I didn't know how to do that because I don't actually use Ggplot. Okay, why? Because I'm old, and B, I can do everything I need with all the other graphic systems. So it's just you pick one or the other, but you can. I know how to use Ggplot. I don't remember all the details, but one of the things you actually kind of do is say, hey, okay, so this is, I don't know, there's a real trick. There's a magic. We all do it differently. This is what I typed into Google. I said Ggplot because I know it's to do with Ggplot. I want to change the legend title. Okay, so this is when we got the plot over here. Okay, we ended up with ordered bath, and I needed to know how to change this. So what did I do? I just typed this into Google, and Google being Google. Okay, I look at this and I see, what do I want? These are all pretty darn good hits. But you know, it makes me happy when I see Stack Overflow as the first one, because there's a good chance that it will actually answer my question directly. And then it goes down, you look at this. How many of you have visited Stack Overflow before? Okay, it's really useful. And it does take a little bit of use, it takes a little bit of experience to actually know how to navigate your way through an answer. But basically, this is the question. There are good and bad ways to ask questions, right? Asking a good question is really hard, but then basically there's some answers to it here. This is an answer. It's kind of got our answer, but not quite, okay? Because it's fill rather than color or shape, okay? So you could infer this. Hopefully somebody has come down and then this is the actual answer. Chick. This is the one that was voted most appropriate, okay? So that's always a good bet to look at, okay? But not always, it's not always the best answer, but it's the one that was voted best at a certain moment in time. In fact, actually, I'm not sure this one really answers the question at all, properly, okay? So this is but as you wander your way through, you also see that there's issues about how much reputation each person has. Go for the guys who actually have answered 12 million questions before. Yep.
I see them assigning a variable for the plot. Why is that?
We'll talk about that in a second. Very good question. Okay. Okay. So this one here, this is exactly what you don't do. Okay, this is like, let me go in and change all the internals of my plot and make it happen, but it'll break in other ways. So there is an art to reading these different things, but here, this is the answer that this tells you, look, oh, labs color equals that, labs fill equals this. Okay, let me try this. And lo and behold, off we go, okay? And the interesting thing is, I would have commented, but my Stack Overflow reputation is not enough to comment, but they gave a good answer. Okay, so this this is how we look this up, okay? So we can actually start building these things. We can start fixing up these plots. We have complete control of almost everything, okay? You can even change whether the gray background, you can have all these themes. You can spend the rest of your life playing with Ggplot, okay? And it's not a bad thing to do because we make an awful lot of plots. You said, why do we assign a plot? Let's do this. Let's just do this. I'm just going to kill this window. So there is no window. Now let's look at the plot. There's no plot. Okay, this is a little thing I mentioned again. There is no plot because I said, do this computation and assign the result to P. Okay, and that, remember what I said? If I say 1 through 3, R says, well, you didn't assign it to anything, I should print the result. So now if I do this, I say, okay, fine, let's call Z is equal to 1 through 3. R doesn't print the result because I did assign it to something. Okay, but I assigned this to P, which means R didn't print it. So let's just look at let's look at what's in P. That was enough to generate my plot. Okay, which was very unfortunate because I really wanted the old window back again now. Okay, because now I've gone and done it. Okay, this is annoying. I'll fix this in a moment. Okay, it's the printing of the plot that actually makes it appear. Okay, and that's very useful. Okay, so why? Because one of the things we'll do it down here, I think, okay, is this, okay? Bear with me for a second, I'm jumping ahead. I'm creating a plot, okay? Creating a plot. So this is a scatter plot, this is X, this is Y. Notice, while we're here, I'm basically saying, here's a plot using this data. It's got here's the X, here's the Y. Lock that down for every layer from now on. We can create multiple layers. Okay, now I want you to draw a scatter plot. And by the way, I want you to inherit the X and the Y from here. But I want to specify the color here. Okay, colored or ordered bath, okay? So you can actually specify the aesthetics in 2 different places. They may actually conflict or one may override the other. That's fine. But now, okay, this is a scatter plot of square foot against price, colored by this. This is one of the things I want to do, okay? Okay. Okay, now it'll be very hard to see. I'll fix this in a moment. Okay, what it's actually done is tiled this. Okay, it's split it up into this faceting. Okay, okay, based on another thing, on another command I added. If I'd done it a different way, I would actually get them stacked this way. I don't know which one I want. Again, you can't see it, and I'm not going to fix it quite yet, but okay. Where are we going to do here? Okay, let's just do this. This is a different way of faceting. Okay, this just facets by the type, and it just goes across as a single row, and it may or may not work. Okay. The aspect ratio is very different. The other version, again, the other version was just this facet wrap with a type and the ncol3. We actually had to use 2 different commands here, one for grid and one for wrapping, so that it would go around rows and columns. But look at this, I got to reuse the same plot without having to redo the actual instructions. All I'm basically saying is build up all these layers. Don't do anything with it yet. Now, I want you to go render it in a particular way. Oh, hang on a second, that's not what I wanted. Take the plot again, the description of the plot, and organize it a different way. And look, this is a reusable object. Okay, I don't need to issue commands to do this. It's fully self-contained. If you wanted to, you could send me this plot. Okay, you could save this object, this P, send it to me, and I would be ready to organize it the way I want. But you've spent hours constructing all these layers. Okay, and that's a very useful thing to be able to actually do. We're minimizing the code that we actually have to repeat to explain all of this stuff. Everyone happy? Let's take a break for 10 minutes. Okay, to come back at 11:15, and then we'll talk about some other stuff. Pardon?
Do you tell people how to save their workspace yesterday?
Just click save when you when you quit. No, I didn't.
Okay.
No, it doesn't ask you and say, yeah, sure.
I guess it does, but a couple people were like, hey, where did my son?
There was another jitter.
There's a thing called Dodge. Yeah, so if you look up Dodge and jitter, and also there is a, if I believe I have it here, and if you Google, but if you go to, and of course, wouldn't you know it, Zoom is sitting on top of me, and getting all. There is if you go here, ggplot2.tidyverse.org, there's a whole reference guide to this stuff. Whether this is enough for you to learn ggplot, probably not, but it's enough for a reference. Okay, so once you understand the concepts, you can actually use these, or you can look at them and say, okay, I should squirrel that away in my head and say, I may need that in the future. Okay, so this talks about the basic functions that you have and the layers and so forth. We've talked about Jom point for making a scatter plot. We also did Jom box plot. Well, there's Jom AB line, V line, H line, bars for bar plots. Okay, and these correspond to different types of plots, but you can also use them in creative ways. So you can go and do a bunch of different things, and so it's worthwhile looking through and reading about these. I don't think it's in my office. There's also the R Graphics Cookbook, which has a lot of interesting, 1-2 page recipes for things, a very easy read, so you kind of can glimpse through and go, ooh, I should remember about how to make that sort of plot. So there's all these different geometries, and then as you go along, so if we search for Dodge, and this is what you can do inside in the aesthetics. You can actually, and in the JOMs, so let's say I think it's in the JOMs, you can actually specify a position, and you can say Dodge, okay, which is overlap, it dodges, it tries to compute ways to avoid overlapping objects and puts them side by side, whereas the jitter, it just adds this little bit of noise. And now we just said jitter, but we didn't tell it how much to jitter it by. We could sort of say jitter by 0.01 up to 0.0 to 0.1 or whatever, or hey, go between 0 and 100, and then we would have got a mess of a plot because all the bedrooms would have gone flying all over the place. So you want to be able to control this, and this gives you options, but these are all things like nudge. Okay, just nudge them a fixed distance. So there's all these different things to try to help lay out. There is another thing, by the way, just, when I look at this, hang on a second. So let's just do the following. Here's a horrible example. Let's just do this, which is read RDS. And I put this into your Craig's list. Oh no, I gave it away. Which is Davis and Sack. Let me just Davis. Okay, so let me just grab this guy. So this just again, this is easy. And let me just grab this guy. You can see this RDS file. I put it up on the web page. Okay, so let's call this Sack. Okay, so let's go off and say, what's the class of this? It's a data frame. What's the dimension of this guy? It's essentially, it's slightly different, I think, but there's 13,000 points, observations. So let's just do the following: SAC dollar square foot, SAC dollar price. Hello. What is going on? Oh, maybe I didn't actually do that. I haven't this one. So let's just do this. Okay. Plot SAC dollar. I don't seem to I haven't computed square foot in this case. SAC of lat of long and SAC dollar lat. I'm just trying to make 1 point here. What do you see here? There's 13,000 points here. Clearly this guy is odd. Okay, but I don't know how many there are. There could be 10 points here, the 15 points or something like that. So let's just, so we can do something like the following again. We can do this in Ggplot or in, let's do this, which is we'll say xlim equals -120. So xlim is equal to -122 to, well, 125 to -120. Okay, and this just controls the thing. Now we spread out. Which has more points, this one or this one? No idea. You can't see anything here, so this is not a good plot, and because you're getting huge amount of overplotting. So we say scatter smooth is a good way to do this. Smooth scatter. And this, and I'm just trying to do this quickly. What this actually does is actually tries to put down densities and shows you how many points there are at each region. We still end up with a lot of nonsense here that we should actually control for. We need to clean up this data set a lot, but we're actually able to sort of see much richer relationships between the X and the Y here. And this is what you should be doing when you actually have too many points to plot. They just all end up on top of each other. This is not good. Or alternatively, when you end up with too many points, we should do something like the following, which, going back to our, okay, this is the thing. We could also break it up by another variable and thin each plot out, but then actually see the relationships based on this other variable. So this is this faceting I was talking about, and so we couldn't see it when I actually plotted because the interaction with the overhead projector changed my resolution. But this is the idea of where we're sort of saying, you know what, I'm going to draw 4-dimensional plots, but I'm going to have a 5th dimension, which is panels for each type of apartment or rental unit, should I say. So here are all the apartments, and what we've actually, this is a 3-dimensional plot, square footage, price. We color code the bedrooms, and then we could easily put in a shape to actually do whatever it is, the baths. And then what we actually do is we just break up the types this way. And then this thins it out a good bit. Of course, each of these is much smaller than a single plot. So we're giving up what we have. And you can change the order in how we do this. So this is Ggplot. Okay, there's a lot of there's a lot to learn about Ggplot, but the point, one of the things we were talking about here is you make a plot, you call Ggplot, you give it the data, you maybe map the aesthetics. If these apply to every layer or most layers, put them in here to avoid repeating yourself. Any layer that you construct will inherit those aesthetics, the mappings of the variables to the different characteristics on the plot. You can override them though if you want. Inside in any geom. There's also ways to I can't remember, did I actually have it here? I think I do. There's also, let me just smooth. I could have sworn I put it in there this morning. Where did that go? Okay, we'll talk about it. We'll talk about it in a moment. Well, actually, so you can you can map aesthetics in any of these elements, but you don't have to because they inherit, and then you can customize all of the different pieces with other layers, and you are just building up layers, and then you get reusable objects as you go along. Okay, so you can essentially replay this code because you've got an object that describes the entire plot, and then use it in different ways. Okay, and that is that. just trying to figure out whether I'll bother talking about anything else. Okay, so any questions? Data analysis. This is you just live off of plotting your data, trying to find weird stuff, cleaning it up. There was one question I had on this plot because somebody asked, how do we get rid of this? So you tell me how you get rid of this. I've told you that basically it's this. This is the plot that constructed that. Okay, take your pick. There's different ways of organizing it, but what we actually ran was this command. Okay, that's the command we made. How am I going to change this so that the NA disappears? How? I like your optimism. I wish it worked that way. Hey, it's much easier instead of saying, no, don't plot the NAs. It's just, if we had a command that says, do what I mean, please. You know what I mean, just do it, okay? But unfortunately, it becomes a little trickier than that. So how do you specify this, okay? So what are we going to do here? So we basically got, so first of all, let's look at this plot. Where does the NA value come from? I see two NAs there on that plot. Two words called NA. It's the type and the bedroom. So which one do we need to turn off? Potentially both, but this is the one we're actually focusing on now. So let's focus on this one. What's that NA from? That's the one in type, okay? Because this tells us the type. The strip here tells us the value of type for each panel or each facet. So how do I get rid of this one? Basically, I just want to say, I really wish you weren't in the data set and I wouldn't have a problem. Remove NA from type, or what if we went over here and said, so we can do this directly in line here, okay? But let's do it in two separate steps, okay? Okay, what if I did this, Davis? Give me Davis, so let's call this Davis.n, okay? And okay, just give it a real name, okay? But I'm just doing. We basically want this new variable to be all of the data frame that is Davis, with any observation removed whose value for type is NA. Okay, and that's harder to say than it is to type. Okay. That's almost what we want, but we want exactly the opposite of it, which is tell me whether it's true or false that each observation is an NA for type. Okay, that's what we say is.NA Davis $type. That gives me 175 long vector of trues and falses, yes? I want the opposite, so I put a bang or an exclamation mark that says invert that, which says, no, I want the one, it's true if type is not missing. Okay, that's exactly what I want. So now I just say, now subset those rows, and by the way, give me everything back. I want everything back. I want all the columns back. So again, it's the same thing we talked about yesterday, and this is what we live off of every day. You just do this thing, okay? Okay, so now we just do this. So what's the dimension of Davis? That's 175. What's the dimension of this? 174. There's one missing. That's it. Life is good. Okay, now let's go back up and say, okay, where do we put this? Okay, yep.
And if you want to remove the NAs in the bedrooms, can you just say is NA dot in type and is NA?
Let's be very clear about what you're trying to say. What do you want to do? Okay, before you do anything in R, try to articulate in your chosen language as precisely as possible what you're trying to attempt, and then try to actually do. So what do you mean?
Trying to remove the NAs in type
as well as the bedrooms. So does that mean? And this is why, to be precise, you have to be careful here. Does that mean we want to remove let's just say identify, and then we'll figure out what to do. Do we want to identify an observation as being a candidate for removal, as being, it has a type which with a value of NA and the bedroom is NA, or that it's either? Which means we change the command very much, okay? Which means, so we basically now, but that we're almost there. We have not is NA type, okay? So now now heads explode because we've negated this. So that means we actually do, so we could write it one of these ways, and this is where you really want to step back. Do it separately, and we'll do this. Davis $type, okay? Okay, that one. Or is .NA of Davis $bath. Okay? That says it's true if either of these is the case. Okay? Now that says these are the ones I want to throw away. Okay? Yeah? So let's just I'm going to do this. W table of W. Okay, we got 14 of these, which is not one, it's 14. Okay, so one of the things I'm going to actually do now is I'm going to go, I don't trust myself here. Okay, let's look at W and let's look at type. And again, if you think I'm doing this just for pedagogical effect, you're wrong. I check these answers every time I do something that's potentially going to get me into trouble. I could easily mess this up. Do I mean and or not? So just check. These should all come back as there should be an NA in every single one of these rows, but not every cell should be NA because we only wanted or. And so there's an NA here and there's an NA there. Good, we got it right. Okay.
How do you create that vertical bar?
How did I create? I don't know. It's just on your lap. It's just there. It is. It's just below the backspace. I don't know. I don't think about it. I just hit it. You can't live without this. This is the vertical bar that says or. By the way, just there's a thing that gets people a lot in this language. This and that are very different. Okay? So let's just do this. So, okay, so let's just do the first one. Let's do it the right way. W1, and then W2 is the wrong way. What's the class of W1? Logical. What's the class of W2? It's logical too, so there's no difference. So what else should I do? Ask for the length. What's the length of W1? What's the length of W2? Ooh, that's not good. Okay. And with the recycling rule, that one becomes the same thing repeated 175 times when I use it, and all hell breaks loose. Okay, so we'll get very bad news. This says, I want a scalar answer back. This single vertical bar says, do it element by element and give me back the corresponding vector with the same number of elements as the inputs. There's a lot of bugs with just an extra vertical bar there and get totally different answers. Okay, but now we have this. Okay, so we've actually now figured out that W1 is the right thing. That says these 14, which are true, contain an NA in either type or bath. So I want Davis.n to be equal to Davis, but not W1. Okay? W1. That was a typo. Okay? So W1 is a long vector, 175. It's got 14. It identifies 14 that I don't want, so I have to invert that. Okay? Everyone happy? Alternatively, if you wanted to, you could say minus which W1. Because which W1 tells me which ones are true, and the minus sign says drop those. And again, this is subsetting the rows, comma, not give me everything in the columns, okay? And now let's go back over here, and we make this plot. But now all I got to do is just change that. Notice that this is convenient. I just changed the data set. And I could have actually done this command directly in here, Davis such the square bracket, not W1, and it would have said no problem. So I didn't even have to create a new thing. And now I'm just going to, now what will happen here? Okay, and the NAs went away here, and the NAs went away in the panel down here, and again, all we did was subset out the bits we didn't want, and then go ahead and do the plot. Everyone happy? What else do you guys want to talk about? I have two things. Yep.
How do we specify the breaks in
The breaks?
Yeah.
What breaks?
How it's shown in the essay.
In what sense?
I mean, if you write, how do we specify if we want break?
So rather than how about we can control absolutely everything. You don't, but if you really want to specify different tick marks on locations, that's fine. But many times we don't actually want to do that. We actually want to do something like the following, which is I'm gonna get rid of the yeah. So we'll just do it this way. One of the ways you could do it is while in. And we'll sort of say, okay, it goes between 0 and 10,000. Okay? And now I've changed the while limits. Okay? So we can change the range of the axes by using ylim and xlim, which are also the same commands for the base plot. So this is very handy. Okay? Is that what you want to do? Okay, but we haven't changed where the tick marks. If we haven't controlled the tick marks, we still say to Ggplot, hey, go make pretty axis labels. You know, go take the min and the max, divide it equally, but don't do 7,502. Round it to real, proper numbers, and it will take care of that. If we want, we can go in and control all the tick marks as well, but don't do that. Okay. But by the way, if you want to, somebody asked me this yesterday. If you're publishing a paper and they want you to actually if they want you to annotate the plot or they want you to actually control these different things, what you can do is you can actually export this as a JPEG or a PNG file and then bring it into some image editor and point and click your way to death and make a plot. And then they come back and then, so the problem with that is you're going to spend an hour or two actually manually modifying this image. You send it off to the journal or your PI or whatever it is, and then they say, can you just do it with this data instead? And you go, are you killing me? I'm just gonna beat you to senseless. Okay, so it's kind of nice. Again, there's a continuum here, and you have to identify when to do it, but you can programmatically construct all of the same things. You have control of everything in R. Okay, so instead of actually manually doing it in Illustrator or something, you can actually go and programmatically do it, and then that's reproducible, and that actually is a good thing. And you have ultimate control, and you're not just actually constrained by the resolution of your screen. You actually can be very, very specific. It's overkill for most things, but it's a good alternative for general purpose, especially if you're going to be if you know you're going to end up redoing the same thing over and over again. Yeah.
It's probably not applicable to this data set, but how do you add error bars?
Oh, actually, not a big problem. Let me just go over and just. I just have something lying around the place, so I just want to just reuse this. Okay, so one of the ways is this sort of thing. Okay, the one thing I will say to you is this is error bars. What error bars?
Standard errors.
Standard errors. There's no such thing as a standard error bar. Okay, there's a whole lot of assumptions that go into all of this stuff and blah, blah, blah. So you have to be careful about what error bars. But yeah, you can do this. This is an example of okay, here we're doing okay, remember, just to practice reading these things, we're drawing a scatter plot, because it's John Point, with square foot and price, okay? And then we're going to color based on the bedrooms, okay? And then actually what I want to do is I want to put a smooth line here. And because when I put the smooth line on, it'll draw the error bars for me. Okay, so in some cases you add a geom, okay, Okay, this is adding an extra layer, which is a smoothed geometry. You can also actually do this where you can actually group by group observations, and it'll smooth different observations and draw a smooth thing for each of the subsets. So you have a lot of control over this stuff. You can actually go over and do something else. Notice, by the way, the message came out of here, Jom Smooth. I'm using method equals LOS. You're all familiar with LOS? No. Okay, so that's fine. So we go, no, actually, what I want to do is I want to use a linear model. Thank you very much. Okay, and now it says, sure, I can do that for you. And now I will actually fit a linear model. I'll put the standard error, the error bars here. So on this type of plot, the error bars is an actual error envelope. Okay, if you have a bar plot, first of all, you shouldn't have a bar plot. Okay. Secondly of all, now you've got counts. So what is the error? There's a kind of an implicit assumption that you've got a distribution of something here. Okay. Is it binomial? Is it Poisson? All this sort of stuff. So you do want to control this. But there are, if we go back over to here, if you go down to, if you search in here and you look for error, okay, Jom, error bar H, horizontal error bars and so forth, and you can search through all the different Joms that it has, error bar, okay, what is the difference here? But again, what I will encourage you is there's a bunch of controls you can put in for all these Joms, like the methods, the smoothing is LOS or LM or LOS with a W and not no W. What the heck's the difference between those two? Okay, but they are different, so that you want to actually understand what the statistics is doing underneath this before you start throwing down error bars and misleading everybody. So yeah, don't worry. This one comes from a normal distribution. I've got 2 observations and their counts. That ain't normal. So so there are problems with some of this, but it's quite easy to add these in. Okay, is what I'm getting at. Happy?
On the LOS, is it like is it the default 95% confidence interval? Or?
Maybe. I have no idea. This is where you actually have to look up the thing. Now, what's actually happening is that, so let's look up the help for Jom Smooth. Jom Smooth says, here's the mapping. Well, we didn't specify a mapping, so it inherits the mapping. Okay. Then there was a data. We didn't specify a data because it inherited it from the Ggplot, the central plot. And then we have a stat. That's another matter. So these Joms and stats have a corresponding, the correspondence between them. So this is Jom smooth and stat equals smooth are 1-to-1. So so it's computing statistics in a particular way. But then we have all these things. Now, when you see ... in the help page, that's when you can pass down lots of extra arguments that aren't identified here, but they'll probably get passed down to this method. Okay, so we can actually take a look and see. And okay, other arguments passed on to layer. Okay, so that they go down to layer, so it's not actually controlling the method here, but then here we have some information about whether it's LM, LOS, and so forth. And then we have to read this help page as to what is getting controlled. Okay, this is one of those cases where you have a lot of control in Ggplot, but sometimes you don't have enough. And then you actually need to take over and actually do the computations yourself. But basically, it's not clear to me how we control how LOS is going to get computed. Okay, and whether or not we can actually pass down extra arguments. The LOS, by the way, remember we were doing the density plot yesterday and we changed the bandwidth to make it more smooth or less smooth? Well, the same thing with LOS, is we're smoothing now X versus Y rather than just a density, and we need to be able to control a lot of these different things. And hello. So it's not obvious how we actually control this. We can control whether the standard error is specified or not. Oh boy, that was fun. Okay, so this is we're doing very high level things, and one command goes off and generates the LOS curve and all the standard errors. Well, we don't necessarily get to control how that's done, and that's a pain.
Is standard error or standard deviation?
What's the difference?
Standard error is the deviation of population mean from true mean, but the deviation is the sample to the sample.
I'd quibble. I would quibble. So the standard deviation can be of a population. You can compute the standard deviation of a population, no problem. Standard error is typically the standard deviation of your estimator. Okay, so it's how much your statistic varies. So that's fine. So this is the standard error of the estimates. Okay, so that's the way we typically use standard deviation and standard error in my world. Is the standard error is of an estimator, okay, which is the sample mean and then how it varies across different samples. And therefore we're always talking, because it's all data driven and samples, that we're talking about about how that varies itself. But it could also be the SD of a different thing within a sample. But no, but we have to read the documentation. Okay. Happy? Well, there's two things that people asked me about yesterday afterwards. One of them is this, okay? And I put these up on GitHub, okay? Remember what we actually remember we had this code, which was this. We had this code to find the rental unit that was cheapest within a certain radius from where I was. And we said, just for the point of fun, we said, here's where we are, okay? We just said, because we couldn't figure out what were good coordinates, but we didn't bother looking up where Shields Library was or where downtown Davis was. So we went through and actually did these computations. And I said, this is fine. And we figured out that this was the right set of computations. We did it, we tested it, we checked it, and lo and behold, okay, so we computed, this is where we're starting from. We computed the distance to all the 175 points in the Davis data frame, okay? And then we said, okay, tell me everything that's less than 0.01 of units of distance. Then I said, which ones are these? Then I sort of went down and I said, okie pokey, okay? I said, okay, let's go grab the subset that satisfies this criterion. Okay, these are candidate things. And then I said, go find me the smallest price in this subset and then go give me the observation corresponding to that one. Okay, this was very useful. Now, unfortunately, we didn't run out and rent the place. So we have to do it again today. And there's a different set of rental units and there's a different set, and I also have the ones for 11,000. So we may want to do this over and over and over again. Okay. Okay. And I may want to do it. I may want to change this 0.01 to, okay, fine. I didn't find anything within my, within 0.101, maybe I'll go 0.02. Okay. So I want to take this and I want to use this code. So I could, one of the things I want to do it on a different data set, not Davis, but Davis today. Okay, different data set. And we also even saw, we also said, hey, you know what? If we subset before, if we take, instead of passing in Davis, if we subset it to have at least 2 bedrooms, then we can actually find an extra, we could actually find within this set that has at least 2 bedrooms, now show me the smallest price for everything within 0.01 units, okay? So we're actually able to reuse this code with a different set of inputs, okay, a different subset of the data. So I refuse to write this code again and change Davis to be Davis 2 or Davis 3 or Davis 2 bedrooms or anything like that, because now I'm just repeating the same code over and over and over and over again. And that means that if I ever find an error in it, or if I ever want to make it do something different, I'll probably break everything that went before it. Or if I find an error, I'll have to change it everywhere. So what do we do? This is a little notch, tiny bit up, but really not hard. Okay, if you followed along with the code that we wrote yesterday to compute that, and again, it was just subsetting and vectorized arithmetic and so forth. I've just copied it basically in here. You'll see it's data $long. I've changed data from Davis to data. Okay, that's great. That doesn't matter. It's just a name. I could have left it as Davis, but I didn't want to. I wanted to give it a more generic name. But it's exactly the same code that I copied. Okay, I changed the 0.01 to be proximity because I don't know it's always going to be 0.01. Okay, so I can set that as a variable and then I could just change that in one place. It now becomes more symbolic rather than actually hard-coded 0.01. So it's a bit more flexible. It's a little bit more flexible and then we just do this and we do exactly the same computation. So almost nothing has changed except for this name, this value. Instead of the literal value, we put it in as a name, okay, a variable, and then the rest of it stays the same. Okay. Then I just change. This is my code that hasn't changed much at all. And then I just put it inside curly braces. That says this is a block of code that is a single unit, okay? And then I say, hey, here's a function. This is, and you see in my text editor and in RStudio, function is a very, very special word. It'll get a different color, okay? For the text, it says, I'm creating a function, just like the plot function and Jom box plot and filter and and the subset operator. These are just regular functions in R. You can write your own, and we're writing it. I basically say, hey, function. It takes a data set. I need to know the observations that I'm looking through. This is great because now it's not locked in on that one Davis data set. It's actually, I can specify different data sets. I can subset Davis and hand in a smaller subset, or I can actually get another day's worth of data and hand that in. Here's the value of proximity. You have to tell me how close you want to be. But I'm going to say 0.01 is a good default. So you don't have to tell me. You just say, here's my data, go get me the nearest thing within 0.01. But if you decide that you're going to branch out and go within 0.02, you can say 0.02 units, okay? But that's up to me, or sorry, to you, the caller. You can basically change this value for proximity or just use the default. And then you also need to tell me where to start from. But you know what? Let's just assume it's Shield library, okay? So we'll just make this function always think it's Shield library, but so that's I don't know, I have no idea where this is, but but that's a good sensible default. It's the middle of our data set, okay? So I just put these in. If you don't specify where to start from, I'll use this. If you do specify where to start from, I'll use that. So I can call this function, okay? So I could call this function as find near cheapest with Davis. And then I could say rpos equals, okay, minus 120 and 38, okay? If I want to control that. Alternatively, if this is always my same starting point, I just say, here's the data I want you to look through. And then when I get to the 11,000 or 13,000, I can just hand that in as well, okay? So, I can now say something like Davis day 2. Okay, and these will all work. Is this clear? All I've done, and I've got a function. I say these are the inputs. These are the parameters that you're allowed to specify. When I wrote this function, gave these names that I was going to use in the body in the commands here. So instead of Davis, I said data and data. So I make sure this code gets changed to actually refer to the variable that I declared, this parameter name. And I gave these default values. So I created a function. Here's the parameters. Here's the body of the function, and typically inside curly braces. And then I said, oh, by the way, let's assign this function to some name. And that's the name. Okay? Now, the unfortunate thing is I never tested this function. So, source. Now I just... Okay, and now I have a function in here. And that's what it looks like. And let's just see. And that's what it gives me back. That's the cheapest apartment within 0.01, okay, of this guy. And then we said, no. You needed to actually have such that Davis dollar bedroom was greater than or equal to 2. Okay, and now, hopefully, we got a different answer. So this function is now, we're done here. We can reuse this all the time, and any time we want. We give it different inputs, and we get different outputs. That's the point. And in my mind, it's really not a big step from, the hard part was writing this code to actually do the calculations, putting a function parenthesis, and then specifying what the inputs are. I don't have to, I didn't need to put this. I could have just put down 0.01. But then if you wanted to go out to 0.02, you couldn't have controlled it. Okay, I could have just locked this down and sort of said our pause is just always going to be the same thing. But I didn't. But this is more flexible. But it didn't cost us anything to actually just say, here's a good default. Let's use that. But you can override it if you want. Okay, is this clear to people? And we also did something very simple. Okay, we did something very similar to this, which is, okay, I said loop over Davis, go through every column in Davis, in the variable named Davis, and count the number of missing values. And there wasn't a function to do that, so we said, okay, I'm going to write my own little function, my own special, but it's so small, I don't even actually need to create it in a separate file and source it in and reuse it later on, although maybe I will. But I basically said, all we want to do is say sum is.na of x. Okay, this says Davis is a list with however many columns. For each column, pass it in as x. And then this code gets to see that column, and it says is.na of x, trues or falses. Sum of trues and falses just gives you the number of true. Okay, then we got that. And this is, we just wrote a little function here. Okay, that is a function. If I'd wanted to, I could have said, hey, count NAs. Okay, except for I have an extra paren. Okay, I've now got a new function that I've written. This is a perfectly good function, just as good as anyone else's function. It does exactly what I want, and no one thought to write this before. Okay, so that's fine. So I do this, and now I can just say sapply Davis of count NAs. And sure enough, I can reuse this function all over the place. I can say, hey, count NAs of Davis $price such that Davis $price is greater than 10. Well, let's say 1,000. Okay, and I still get none because it was none in the first place. But I can reuse it in different ways. Okay, this is how easy it is to write functions, and you can put them into a separate file and reuse them over and over again. So once that function becomes useful to you, you just lock it down and it's over. Okay. So, any questions about writing functions? They're hard because the computations they're doing become hard. But I'm hoping that this part is easy. Here's the name of the function. I declare this to be a function. I put parentheses. Okay, I need some inputs, so I could just stop here. And then this was the hard part. This is one we actually had to think about for half an hour to actually make the computations reliably correct. Okay, but other than that, this ain't hard to actually write. And this one, how many NAs? That's an even simpler function. This is the one we just wrote. We put it in a file, we can source this in. It just takes one argument, no extra things. You can only specify its input, and it assumes a vector, and it just goes ahead, does its thing, and gives you an answer. For those of you used to other programming language, where's the return statement? There isn't one, you don't need it. Where's the curly braces? You don't need it because there's only one line in this function, so you don't need it. But these are kind of throwaway things that you can actually use them over and over again. Everyone happy? What do you want to do? Pardon? Heat maps. Heat maps. That's very specific. We could talk about that afterwards, as opposed to it's not necessarily a thing that everyone needs to do. There's one other thing. Again, feel free to leave. There's a person who was here yesterday had a problem. Okay, so which is, here's a data set. I gotta remember where it is. Okay, this one. Here is a data set. Here's a date time separated by a comma. So this is all one field. This is a CSV. You can tell that because it's called CSV. Okay. which is no, you can't tell it's a CSV because it ain't a CSV, by the way, because you can tell because it's got a whole lot of garbage at the top. So there's no standard format for a CSV, okay? There's claims to have one, but that's fine. But it's close to being a CSV. That's the trouble. It's so close to being a CSV. Comma separated values, comma, this is a value, this is a value, this is a value, this is a value, so forth. How do I read this into R? Because you can't go anywhere. All the stuff we've talked about, subsetting and plotting and all that sort of stuff, you can't do anything if you can't get your data in, unless you're simulating data, which is fine. But even then, you need to program stuff. How do you read this into R? Very quiet. What's a strategy? This is about strategy, okay? There is a function. So I was nice to you. I gave you an RDS file, which was already pre-processed, and it had the dates were actually formulated as dates, and the factors were formulated as factors the way I want, and the title wasn't a factor, so it was easier to deal with. The trouble is somebody had to read that data in and then do the processing. This comes to you where you could load this into Excel, you can load this into Python, you can load it into any other application. So this is a universal format, but unfortunately it's not quite the way we want it. But there is a function called read.csv in R, and it takes a regular CSV file. In fact, I'll show you. Here's another version of this same file. This one was actually manually edited to actually contain to take the same data that we just saw and make it easier to read into R. So this is a lot of work to manually edit this. They did actually add in some extra columns, which is even harder. Okay, so this is a pain. How would you read this in? So let's just deal with this one first. But I wouldn't do this because I'm not going to do anything manually because I'll make errors, because manually doing something means it's going to be error prone. And secondly of all, I'm never going to be able to reproduce it. Okay. And I know somebody is going to keep giving me these files. Somebody says, oh, I got this file, can you read this? And I say, will you ever have another file like this? And they say, no, 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 no. And then the second I finish doing it manually, they go, oh, I have 1,000 other ones. That's amazing what you did. So can you process these other ones? So no, we're going to do this programmatically. So I would start with real data set and actually come up with a strategy for reading it in, which is not overly hard. And it uses all the same tricks we were using for the last 24 hours. Okay, subsetting, finding patterns, finding the things we want. But what about let's just read this one in. Read.csv, flow edited.csv, and I'm going to turn off these. Well, we'll just use the default. Okay, there we go. We're done. Okay, so what do I do next? Class. Is that what you said? Absolutely. Okay. So, class, because this is the thing I do. Did it work? Hopefully, read.csv either should throw an error or give me back a data frame. That's fine. So next thing I do is dim because it's a data frame. So okay, there's 12 of these guys. Okay, names of D. There we go. Looks pretty good. Looks pretty good. There's a comment at the end. Okay, fine. What do I do next? My next step, I've shown it to you a couple of times. What's my next step? You can do it in one of two ways. Is that what we expect? This is one way of doing it. I asked the more specific question, which is more limited and more specific question, which I find easier to understand just because I don't see all this extra nonsense, but it's still pretty good. Even that actually, but this is actually quite useful. Both are very useful. What's funny about this line, let's say? Pardon? So it's what's the class? It's a factor, which means it's what? What does it correspond? It's a categorical variable. And here are the first couple of values. Do they look like categories to you? Something's gone wrong here, okay? This is not good news. So the person who did this, was just showing it to me because it's a nice example of, okay, I just assumed it came in nicely. So then they had to multiply velocity by 1.07 to correct it. Well, you do that, but hang on a second. You can't multiply a factor. It's not a number, okay? So we say d dollar velocity multiplied by 1.07 should just, okay, and we get hello. And we get this warning message which says it's not meaningful for factors, and that should have tipped us off, but it would have tipped us off if we did this. We read the warning messages, read every warning message, because it's nearly always an error, okay? But notice, because I know the punchline for this, I found the error before we ever did anything. I said, this didn't work, okay? I anticipated that velocity should be a numeric vector, and it wasn't. And I saw it here because I did some diagnostics before I went further. So what happened? How would you fix this? Now you got your sleuthing hats on. They're all very quiet. What's my first strategy? Rename the class? How do you mean? So d dollar velocity, I just basically say what? What do you want me to do? I like your... Here? So I could do this, something like this, which is I could set the class. This will do something, okay? Okay, d dollar velocity. Now let me just take a look at the first some of these, okay? Is that what I wanted? That's the first line, and velocity is the second element. So we went from 0.38 to 151. Okay, good idea. And you just try things, but you got to have a backup to check, did it actually do something right? You can't break anything, because all I've got to do is, okay, I've now actually destroyed D. Okay, so let's go back. That was the great thing about actually having my code in a script. Let's go back and start again. Okay, now I've recovered to where I was. That didn't work, and and if you want to know why, I'll tell you why. But it just didn't work. So let's move on. Okay, but you're on the right track. Why don't we just turn them into numbers? Okay, just setting the class might be a little bit. You were guessing what that might do, and it took a few shortcuts that we needed to do a bit more. What if we did the following? What about, let's just try this, 1.232, okay? So there's a string, and it's got that, okay? There we go. It got it right, okay? What if I do the following? It's 132. What if I put in ABC? Again, you can do tests. Just check. It says, that's 1.32. This is a missing value. So that gives me a hint. And this, by the way, this is just a generic approach that you can use, okay? Okay, let's do the following. Let's do as.character of d dollar velocity. So I'm just going to actually say, yeah, forget the fact that they're factors. Just turn them into strings, okay? Let's just go straight to strings, get them back. I could have done this, by the way, it said, something's wrong here. Read.csv, and I could have said strings as factors equals false. Okay, look, I'm in diagnostic. I don't want you to do the right thing. I want you to do something so I can fix this up. But I can also just do it this way, okay? So now I'm going to do this. I'm going to call this temp. And now I'm going to do the following. I'm going to say now. So let's just take a quick look at this. There we go. Okay, these all look like numbers to me. I don't know why R is so stupid. Okay. By the way, how big is D? 16,000. It seems like a good enough random sample. Just let's look at the first 6. They all look like numbers. What could possibly go wrong? There's only another 16,000 later on. Okay, that's probably going to be our issue, is that we're only looking at the top of the file. So let's do the following: as.numeric of temp. Okay, and let's call this vals for we're just going to throw this. Oh, hang on a second. That wasn't good. We got the NAs. That's why I did this thing earlier on. I said, if we give it something that it can't turn into a number, we get an NA. So let's go back and look at temp, which is my character, where vowels is missing. This says which element in vowels is an NA, which then go back and let's look at where it came from, which is temp, the corresponding element in temp, and you go, oh, there we go. Now that's my problem, okay? When somebody edited this, they forgot to take out these lines, okay? Where are those lines? There you go. So this, unfortunately, is a status report or message from the sensor that's actually delivering this data. So this is not a CSV file, and but it is close enough because this is in CSV form, but this value is messing up this entire column. So what do we do? I remember this was done by hand. This was edited by hand. 16,000 lines somebody went through and they missed. Oh, they only missed 16. But how do I delete them? So I can, okay, okay, let's suppose there's 1,000 of them. So we want to delete them, we want to ignore them. But I want to do it by hand. And again, you know, do it whatever way makes sense, okay? But I guarantee you that this person may have gone through and actually removed 1,000 of them and missed 16. Because, you know, you get tired after a while. You're just kind of like, I'm bored. And these may be at the end. In fact, actually, I wonder where they are. Which lines do these correspond to? How would I find which line numbers? There may be some pattern to this, maybe not. Well, I can just say, hey, which is .NA of vowels? Okay, they're the line numbers. So, oh, some of them are near the end. Okay, fair enough. Oh, some of the beginning. Okay, no pattern. Okay, that's fine. So, what do we do? Do we fix this manually edited file? Do we go back and read the real one? Do we fix this by hand, or do we actually do something clever? Do something. I don't know. This isn't clever to me. We can fix it here. Okay, we could if we wanted. You know what we could do is we could do the following. We could do our problem is this. Let's just do this, which is flow edited .csv. I'm just going to read the lines in. I'm not going to read the data. I'm going to just read each line of text as a string. Okay? Okay, so let's LL for lines. Okay? Now, my problem is I don't actually want the ones. I want to exclude the ones that contain the word note in them, N-O-T. How do I do that? I don't want to, let's not exclude them first, let's find them first. How do I find whether note is in a string? Let's take a look at LL of, I'll look at this one and the one before it. So it's 736 to 737. Okay. Why didn't I get the right answer? Why is that wrong? Oh, let's go to 738. Okay, there it is. Why? Because this number up here corresponds to the row number after I've skipped the header. So, okay, fair enough. Okay, good, okay. There it is, that's the one. So, okay, how do I find that note when I don't know what it is? So this is a very weird, very, very, very weird thing. One of the ways you could do it is you could actually break up every single letter here and look for N followed by O, followed by T, followed by E, okay? I'd have to write code to do that, and this is seriously ugly code. Let's just do this. Don't ask why. Okay? Those are the lines. They're almost exactly the same lines, except that I add one to the ones I found before. What does grep do? Let's just grep, okay? It pattern matching and replacement, search for matches to argument pattern within each element of a character vector, blah, blah, blah. What the hell is this? I have no idea what it is, okay? This is a very weird language within R and many other systems. It is a way for us to search for patterns like N followed by O followed by T followed by E, but it's really fast, it's really easy to use, we don't have to do the computation ourselves, but it can find really clever things like an N followed by 3 O's, but not followed by an X, and there must be 6 digits at the end of the line. Okay, that's a very powerful pattern, but you need a little bit of, you need to express that, and you have to learn a very small, tiny little language, a weird language, but very powerful. But this one is easy. Just go find the N followed by O, followed by T, followed by E, and then we're done. So one of the things I can do is this. I is equal to that. That's the row numbers. Now if I do LL of I, note they all have the notes. What I actually want is not I, everything but the I, don't I? Okay. So what I can do now is I can just say LL equals, okay? So I've basically got rid of those lines, the offending lines. I hope those are the only offending lines. We've only done one column. There could be more, okay? But one step at a time. So I've done this. Now what I could do is I could write them back out to a file and then read.csv. We can do that if we want. So I can say cat LL into file equals temp.csv. And now I'm going to do read.csv of temp.csv. We won't bother with strings as factors. And I'm going to say D2 equals this guy. What the heck is going on? Why is this so slow? I have no idea why this is so slow. That's not good. This can't be good. I have done something goofy. Okay. Oh, that was one of the things I did very badly here. Okay. So it's clearly very, very sad. Okay. So I made a mistake. What mistake did I make? Anyone see what mistake I made? How many lines are there here? Oh, it is very unhappy. This is all on one line. Oh, okay, that wasn't good. Okay, so let's just, okay. So we made a mistake. Okay, so let's go back and say, sorry. We say, put a separator in, please. Now, oh, that's much better. Okay, so you have a sense, okay? So what's dim of D2? It's that. Now let's take a look at head of D2. Head, if I could spell. There we go. Doesn't look too, ooh, this is looking a bit better. Okay, now let's do supply of D2 of class. Everything's the way we want it to be. Okay, that was a handy little trick. Okay, because we're using data analysis and to actually go and find the offending line rather than actually, because we didn't even know what we were looking for. We didn't know what the problem was. We just said, this isn't coming in the way we expected it. So we just, what do we do? The strategy was look at the thing that was causing us grief, try to find the values which weren't numbers. Then we actually identified what the characteristic of those lines was. We said it has a note. That's why it couldn't convert them to numbers. Then we went in and found them in the text. Okay, and then we in R, we not by hand, but in R, we said read in all the lines, throw those lines away, write them back out to a file, and then read them back in again. So we've actually fixed that file. Hey, can you figure out how to read this one? What would you do to read this one? This is where it starts. Well, no, not really. This is where it starts. This is starting to look like a comma-separated file. This is all metadata, extra stuff at the top. So we want to skip those. So we want to find the lines that start with a bang or an exclamation mark. That's common, I'm guessing. Okay. Actually, I want to keep this line. These actually are the names of the variables. So I want to read those once because I don't want to put the names of the variables here. Okay, and I want to skip anything with a note in it again, and then I go on. Who knows what's going to happen? Well, we can do the same thing again. This grep command is really powerful. And if you want, I wrote this all down in a markdown file as to what the strategy is, but it just so we can go through it quickly. But one of the things we can kind of do is this. Okay, read lines of the original flow.csv. By the way, single quotes are the same as double quotes, but you have to match whatever you start with, you have to end with. Otherwise, you can't mix a single quote and a double quote at the end. That's fine. LL equals this guy. How do I find those exclamation marks? Bingo, that. Okay, grep in LL for that guy. There we are. Let's get, ooh, hey, I didn't spot those ones down the bottom. That was me. They finished I don't know how many lines there are. How many lines are there? We can ask. Ooh, look at that. The last couple of lines have these comments. We would have missed those if we hadn't gone all the way down, when we gave up halfway through. So, there's comments, and then, and look at this one right in the middle of sort of the real data. We probably would have missed those. Okay, so now we can actually just say, okay, fine, then give me all of those guys, which is LL minus I. Okay, that's good. We could actually, now we're back into this, hey, we haven't found those guys, so let's look for the words with note in them. Okay. Note in here. I is equal to this guy. That's not good, actually. Hang on, let's just start again, because I didn't actually assign this to I, so I was using a different file altogether. That's not good. Okay, we get rid of that guy. And now we go back and get our note. LL equals LL minus I. Let's just see if there's any notes left in there. Did I actually get this right? Nope, couldn't find that. Find this. Okay, life is good. Dang, I threw this one away. I should have grabbed that one. Okay, I should have kept that one. Okay, but now I can write this out to file, read it back in again. Alternatively, here's a nice little trick you can use, okay, which is this. We're just gonna, don't worry, we're gonna do this, read.csv on this guy. There's no header for this guy, so I'm just gonna say D3. And that seems to have gotten it approximately right. We'll see. So we're in good shape now. The only thing we want to do is actually go grab those grab the names. How would you get those names into the data frame?
Why did you enter that the header was true, no header?
Because, okay, so you can read the help for read.csv, okay? And again, this is the vocabulary and the annoying vocabulary that we have to read. Header, a logical value indicating whether the file that we're reading contains the names of the variables as its first line. But we chopped everything out, so it didn't. Okay, so because this particular file has the first line. Well, we got rid of all these lines. And then we got rid of these lines, and then this was our first line. So it's not the names of the variables, so this is bad news, okay? So how would you get this? How would you get the variable names in here? There we go. Oh, I was hoping you were coming back. How do I get these names onto the column names of the data frame? I know how I do it, okay? And I do it programmatically. What's the better way to do it? Cut and paste. Okay. I'm not going to write code to actually go and bother to do this. Okay. I was like, come on, this is way too much trouble for this. Unless these change and I got millions of files and these all have to work that way. If I happen to do this, I could actually say, okay, but do the most obvious thing, which is just cutting and paste these things open. If these are very, very big files, you may not actually be able to load them into anything to actually be able to cut and paste them out. But basically, let's just do this again, flow.csv. So I'm going to do A is equal to this. Grep for bang names, because that's the guy I'm looking for. In A, It's number 11. So I'm going to say A of this guy. That's my guy. Okay, so let's call this B. And there's another little function here called string split or stir split, which is on V. And I'm going to say split it by comma. Look what I get back. I get back all the elements I want. It's kind of weird. This is a list with one element whose contents is a vector. And that's because stir split will take in a character vector and split each one based on this character comma. And they may have different amounts of number of elements. So they has to come back this way. But hey, let's just do this. So how do I get rid of the first one? The bang names. But what I need to do is I need to add the date. So what do? There we go. We've got our names now. Okay. So again, programmatically, we can manipulate these things. I tend to find reading data into R is one of the most complicated things because the data don't come in simple form. Somebody else may give it to you as a CSV file, in which case they've done all the hard work. But in many cases, they don't. For example, this is the data that we were playing with from the Davis rental units. This is what they come in as. Okay, you tell me where the square foot is. Okay, or where the laundry is, or whatever it is. Now you'll see why the square foot and the baths didn't come out quite right at all moments in time. Okay, sometimes they're not there, sometimes they are. But this is where we get a lot of data from, is scraping the web. Other times we get data from these funny machines, which have a totally different file format, but they're close enough so we can do some magical repairs. If you're trying to read the HTML files, don't come and talk to us because it's a pain. Okay, there are good and bad ways to do it, but they're fine. But you notice what we did, if you read through the notes I wrote on this, how to manipulate flow. You didn't know about the read lines function, but it's just, okay, that's fine. But look, the grep function is also really powerful because it can find these text patterns in many strings and identify which ones match and not. And there's a whole other set of functions for grep. But actually after this, and the stir split, but after this, it's just subsetting. It's just playing with subsets on little vectors, but they're no longer they're not data values that we care about. They're actually text that we care about to get the data values. So it's really an awful lot of this stuff is just subsetting. Anyone got any questions? You're very quiet. No? Well, if nobody's got any questions, I'm going to go to lunch. So I'll be around later on this afternoon then from about 12:30 onwards, if you want to come back and chat, come back and chat. We can go through any questions or exercises that you want. Otherwise, but if you don't come back, then I'm going to go home early, which is even better. Well, I should be here till about 2 o'clock unless people come back, and then I will stay until 3 or 4 o'clock. Have fun.
Thank you very much.
You're welcome.